Everybody hear me? All right. So as you can see, I'm not Paige. I'm a pretty ugly version of Paige. unfortunately, she got sick and couldn't make it. So she pinged me and asked me if I'd drop by and do this talk. It's one of our talks that we use kind of around the world to introduce open telemetry. It's a very basic 101 talk. And anybody here working with open telemetry in depth? You are? So you're just coming to validate me, make sure I'm not lying about what's going on. Anybody here have no idea what open telemetry is? In between, in the middle somewhere? Yeah, okay, good. This might be a good talk for you then. All right, so what we're going to do is we're going to look a little bit about the foundation of what we talk about when we talk about observability, kind of set the baseline, right? So what is it, and what it looks like in the beginning, and then what it looks like when you start scaling it massively, right? This is kind of an important aspect of what's going to happen when you start working in the observability space. How many people here are doing observability? Engineers or SRE. Is anybody an SRE? I always ask that because anybody puts their hands up as an SRE, these are the people you need to be nice to. These are the people you need to buy beer for. How long have you guys been doing it? Several years? 3 years, okay. I had a really funny answer one time when I asked someone that. He said 10 years. I was like, oh my God, how did you handle that? How do you, he goes, well, I do it about a year and then I go become an engineer somewhere else for a year and then I get tired of that and come back I was like, so you're like getting rid of the burnout, right? It's kind of a stressful job. Then we'll get down into the nuts and bolts of open telemetry, what it is. The only thing I'm not going to talk about is committing to open telemetry, what the code's about and stuff like that, okay? This is not a 101 on how to do open source. So this is really on the focus of how you could get involved, such as talking to people, what the different events are, where you can find them, that kind of stuff. So maybe the SREs can back me up on this. I've always felt like Cloud Native was this great big promise, like this ice cream you get as a kid. And then when you start working with this stuff, this is what happens. Am I far off? You know what I mean? It's kind of frustrating, right? It's really, really, really fun when you're doing it at the beginning, right? You're building these beautiful little container things, apps, you're able to monitor the shit out of them, it's not a problem. But it's not reality, right? It's a little bit rougher than that. Anybody here looked closely at one simple app on a 4-node cluster? If you Google around online, you can find several examples of people who published stuff about this. I also put these slides online. If you look at my Twitter feed at all, it's my first name, my last name. You'll see it at the end, and you can find it. I already posted them online. In the speaker notes, you'll find the link to this specific example. But it's just a hello world, just a simple web app. It's got a simple script that's pinging it every once in a while so that you can get user metrics, you can get back-end metrics, you can get service metrics. Very simple collection of stuff. And it does this for 30 days, and then he added it all up, and it's almost half a terabyte of data. Just metric stuff. We're not even talking about the production data that you're doing for customers and earning stuff and tracing what they're doing, right? This is nuts if you ask me. I come from the app dev side, right? When we build stuff, we don't care about this. Never looked at it, never thought about it. Somebody might ask me to put something in for metrics, fine. We do that, we don't care, it's part of the functionality we're supposed to build. But wow, doesn't this blow your mind? And then you hear about places like Uber where they have millions of these things. What's going on? How are you able to find that needle in the haystack when shit breaks? Ask these two. Give them a beer, ask for some stories. They have them. It's not just the volume of data. They did some research, and on average across the world, people doing this, the retention rate is 13 months. And generally speaking, most companies start with a simple rule across the board, like everything has to be kept 13 months. That's just policy. But what about those development environments you have where you do training for 2 weeks and then close them down? And then you keep the data for 13 months. You're paying for that storage. You know what I mean? Everything through the pipe is money. So water through the pipe costs money. The more water through the pipe, the more money you got to do. How many people are living in Europe right now? About half. So speaking to you guys, it's like your energy bill right now, right? It's gone through the roof. Gone through the roof. Pretty nuts. And then it turns into this. So that beautiful environment you had scales like crazy. Whatever happened, you started getting famous, your company's exploded. And what does Cloud Native do. It automatically scales when needed. So then you end up with all these tools, all these containers, all these things. And then we step back and we look at Ollie, right? The observability. It's wonderful when you have just a couple of things. You can think about it, you can plan for it. You all start out with a great plan. We all do. So it feels like a holiday, right? You got a glass of wine, you're watching your dashboards, it's fantastic. And then it scales, right? And I've given this talk several times and people come up afterwards, usually the SREs and even one SRE manager. And he goes, it's exactly like that. And I don't want to traumatize anybody here with war pictures, but it's basically, I was looking around for a burned out building and this is what I found. But it's so hard to keep up, right? Let's look at why some of this stuff is happening. It's utterly remarkable when you look at this, how many companies have all this data for what they're doing with their customer, and then as it starts scaling, all your observability data and your storage and stuff prices go up here. This has nothing to do with making money. This is your burn rate. This is over here engaging with your customers. And they're hitting that point where it starts getting more, and they're like, wait a minute, we got to do something with this. And really shocking, at the end of 2022, I saw an IDC Cloud report where they said, I think 80% of companies in Europe were looking at doing a FinOps role by the end of 2023. To me, that's panic button. How many people have seen 80% on an IDC report? You know what I mean? Usually 40% is a trend. And 80%, I was actually watching this thing on the side while I was working, and I actually did a whiplash thing when I heard her say that. I was like, what? Who's going to put a FinOps person in place? That has to do with getting control of this. The problem is in an organization, you don't know what everybody's doing, and they're going to a marketplace and pushing a button. And I got several stories around stuff like that where they decided, hey, we're going to use this load balancer. And then they had to add metrics tags to it. It could only support 200, so that means you're load balancing the load balancers just to trace down these tags for security operations. It's crazy, right? Oh, too many. What we really want is something like this. Does anybody know what this is? I'm in Europe, so y'all should know what this is. Yeah, exactly. So this is a really old city, right? This has been around a long time. So this has had to scale and grow. But look how nicely they've done that. This is what we want our observability to look like, right? We're trying to achieve that nice steady growth. We have organization. We know where everything's at. We know how it works. We can find what we want to find. And we're not spending too much money on it. Let's be honest. Nobody cares how much it costs if it's doing what it's supposed to do, right? If I can solve problems faster, if I can remediate quicker, if I can make more money, customers are happy, they'll pay anything, right? That's not the problem. The problem is that's not happening. So let's get down into actual telemetry stuff and what we came to talk about. That was just setting the table so you know what this is about and why people start looking around at this. So telemetry, this is a definition just to get us all on the same page. It's basically about looking out there and collecting information so we can monitor and control systems, right? Sounds easy enough. Let's look at what we're doing in open telemetry. So we have one expert in the back and the rest of you have never seen it before, but open telemetry, this is an open source project that's in the Cloud Native Computing Foundation, of course. The whole idea here is focused on cloud native computing. You'll hear an awful lot about microservices, right? And how do we do that? Microservices are being sent out there, they're individual containers, and they're often doing calls that bounce between multiple containers, and you have no idea the path it's taken. This is set up to be able to trace these paths, to be able to monitor what these individual calls are. So you call it once and it goes ABC, you call it a second time, it goes A, D, E, F, G. You never know. I remember very distinctly about 15 years ago when one of my friends was working for one of the very early JBoss projects that did that stuff. And he was super freaked out and frustrated trying to trace this stuff. How do you do that? It's really hard to figure out where stuff went, live and debugging as a developer. That's what this is for. They have a really good doc set up. I'd encourage you to go look at it. It starts with the first question, are you operations focused or are you developer focused? And it takes you on the path you need to do to go look at that stuff. One thing I say up front, because most people don't catch this when they're digging into this stuff, is it's not a backend. So by backend, I mean this is not the collection and storage of your metrics. They're on the front end making sure you can get them all, but then he wants to either push or be pulled from a backend. So you can send it to Prometheus, all that kind of stuff. So you'll see that listed in there, but be really clear, this is not a backend. It's not a full-blown solution. It's just concerned with being able to trace what you're doing out there in the world with your microservices. So a couple of other things you're going to hear a lot about, traces and spans. So it's really important to understand that spans are those little units of work that we're defining between this point and this point. This is what I'm tracking. And then when we want to do a trace, so if all the way to we collect a bunch of these spans over time. Okay? Pretty straightforward. So we get down into what OpenTelemetry actually is. It's these three things. It has a specification, and in that you'll find an API you can work against. You have an SDK in case you don't have the language you want to use isn't covered yet. You can build some of your own stuff around it. But it's been around long enough, there's a lot of them already done for you. There's a whole list of them in the docs. And then they have the OpenTelemetry protocol. Anybody here an architect designing these kind of systems? You love to hear open standards, right? That's kind of the way you want to lean in any kind of solution you're putting together. That means if later they come up with better stuff, they'll probably stick with the same protocols and try to continue onward, right? So you can replace that without having to worry about that. Super important. So let's look at some architectural stuff because we all like that, right? And nobody freak out about the arrows because I've gotten a couple times that people have asked about the arrows going this way or that way. It kind of depends upon how you're using them as we see more of these. This is taking a big high-level view at this where you see your application. Now I'm an old Java guy, so I chose a Java app by default. And you have something called auto instrumentation library. So instrumentation is when you're inside of that application, putting stuff in place saying, this is where my span starts, this is where my span stops. So this is what I'm tracking inside this service, right? So an auto instrumentation is stuff that's been already pre-programmed for you if you're too lazy, or you have existing stuff you just want to turn on. So you put the auto instrumentation in and it does default stuff for that language. May not be exactly what you want out of the box, might be enough. Might be too much, you have to cut some of it down. It's up to you. You also have an OTel API you can use, and you also have the ability to SDK it if you want to build something extra or new or whatever that's not existing. And then you have what's called a collector. So that sits next to the application, in this case on the same machine or the same node, and this thing is collecting everything you got. We'll zoom into what that's doing in a second. Now these collectors, when you look at them, you have two kinds. You have an agent and you have a gateway. Now, if we're looking at one host, one node, one machine, then you're going to put an agent on there, and you're going to have your applications on there, and they're going to be collecting everything to that agent. And then you have, as I said, that doesn't have a backend, so you have to push it somewhere. Or you have to get it pulled, scraped from a Prometheus instance. So, for example, if you're using something like, I don't know, Datadog or whatever, you have to probably push, and Prometheus is a pull. Make sense? That's what I mean about the arrows here, right? So in this case you're pushing, but it'd be the other way around if it was Prometheus. I didn't mean to put too much meaning on that. Everybody with me so far? Open standards everywhere, nice things. What happens when you use a gateway? Now imagine you have a whole bunch of clusters out there or regions or whatever running. You'll be doing all your collecting with your agents, but your agents need to be coordinated with a gateway. So it'll be one gateway per region. Gives you more filtering capabilities on regions and stuff. And we'll get to that in a second. So it looks like it's getting more complicated, but basically it's the same idea. Just one more step in between. Make sense? All right. Now what's it look like inside this collector here? So you have telemetry being collected, spans, traces being put together. They come in through something called a receiver. So that picks them up, and then you have the ability to do something with the processor. The processor's a really good example is security-based. You don't want to have data being streamed back across regions and stuff like that with privacy information in it or security information in it. So you can pre-filter that before it goes back. You might have just auto-instrumentated and decided, hey, I don't need half of what's going on here. I'm only interested in this, this, and this. You can start aggregating out your metrics right there. You probably get a little bit of feel if you've done this before. That's not going to scale very well if you have to do that by hand and make all these preprocessors. And then you have an exporter that is passed on to that decides what protocol, if not the open telemetry stuff, it needs to be sent. At that point, you can actually use, there's a whole list of exporters in the documentation. For example, if you're using Datadog, then you have to use a Datadog exporter. If you're using something proprietary, you can build your own. It's whatever you want to do, whatever you need to connect to your back end with it. Any questions about this? Pretty straightforward, eh? It's not as hard as you thought it was going to be. So this is a visual thing to get an idea of what these spans and traces look like, not going into great code detail. You have two different forms. One's it's like a tree that's being built up as it's stepping across all these services. Our brains tend to work a little bit better here with the timeline. So you see you have a complete trace, and you have a bunch of spans inside that trace. So you can see that this thing jumped from B to C to D to E as it worked its way through what it was doing for this application. Not too hard, eh? And then you have the ability also to use a Kubernetes operator. So there's predefined nodes that have a collector and auto instrumentation for all different kinds of languages. You just pick the operator you want to use and off you go. Simplest way to get started. Might not work exactly how you want it. You might need stuff that you need to adjust. Might want to make your own. You know, it's just kind of depends upon how far you want to go. So how can you get your feet wet here? This has to do with getting started inside of the project. Now, as being a CNCF project, they do a whole lot of stuff within their Slack channel. I just did a real quick search on OpenTelemetry, and it's just oodles of stuff you can find in different groups talking about different aspects of this. Whatever you're working on, whatever you're looking at, there's someplace you can go have a chat, right? It's pretty straightforward. Also advertising for the next KubeCon, but we got a KubeCon coming up. It starts tomorrow, I believe, with the pre-events and then on to the actual event of KubeCon. But you'll see a lot of stuff about OpenTelemetry there and stuff. You can get down into the nuts and bolts. KubeCon, you'll see a lot more presentations that have to do with, you know, doing stuff deep in the code. There's something called special interest groups, SIGs. Right? There's a pretty interesting one going on right now. They're talking about not just for OpenTelemetry, but I thought I would mention it here about talking about it's under tag observability channel, and they're talking about doing a query language, so the communication language for all this stuff, and it's going to affect everybody inside of the CNCF if it's successful. So standardizing, right? So you see the OTel one. You also have PromQL for metrics queries. You have a couple of standards out there right now, and they may not be official standards, but they're unofficially accepted as standards across the world, right? People are using them for all kinds of stuff. So very interesting to dig around in that kind of stuff. And you even if you're just listening, right? It's not that you have to participate or whatever, but it's just interesting to see what they're talking about and have meetings. It's all public. And then you also have the end user community and stuff. Anybody seen the one they put about it? I wouldn't even try to put it on the screen, but they'll do that at KubeCon. They try it every year. There's one with everything every project, every person involved, every company that's involved. It's pretty much an eyesore. But this one over here is just the end user community. That's another way to get involved or another way to see what's going on. These are the people that have committed to using it and supporting it and that kind of stuff. There's also a lot of those. So, any questions? One in the back from the guy that actually works with it. Now I'm worried.
Well, thanks a lot for the interesting talk. And since there are no questions, just a few comments, if I may add to your invitation for everyone to participate. So Tuesday, tomorrow, there is the we're holding the maintainer the project meeting. So everyone is invited to come. It's I don't remember the time. I think 4 p.m. At the Congress Hall, and you can just come and share how you use OpenTelemetry, what you wish to see from that, discussing the roadmap with the maintainers. Highly recommended for those who are looking to get involved. That's a good way to get your feet wet. And Thursday, there's going to be the talk by the maintainers about the project update. So another good place, but this is less of a discussion, more of a formal talk where the maintainers will present the latest on OpenTelemetry. So highly recommended for those who want to follow up. And on the end user group, there is actually a survey, an end user survey that if you want to, again, pitch in and provide your feedback on how you use, how you want to use, it's still open and collecting the information, and then it will be published by the OpenTelemetry community. So lots of opportunity to participate, and if you have any other interest, that I'm happy to also share more finer grain details if you want to do that. Thanks.
Yeah, no problem. And I don't know if there's any talks at the Open Observability pre-event. Yeah.
And tomorrow, the Tuesday is the co-located events day. So there is a co-located event. I don't know if there's still tickets left if you haven't registered, but a dedicated observability day. I'll be there as well. Assume you will as well.
Yeah.
So if you are passionate about observability specifically, there's a designated day tomorrow. Lots of conversations about Prometheus, about OpenTelemetry, and many others. So that again, and also during that same day, but not on the observability day, they will have also the maintainers discussion, the project discussion.
Yeah, and it's also live streamed, so if you can't get in, you can watch it online at home or at work.
Did you just say there's no tickets left? Okay, so that
But you
appears to
can
be sold out.
you can live stream it.
Let's try it, live stream it.
Yeah.
Maybe not participate, but listen in.
They're streaming all of that stuff, I believe. Yes.
Question on the size of the data, because I agree that suddenly we have like 500 gigabyte of data with the Hello World app, and it can be huge. But is it that we are now collecting more and that we were not collecting anything before, like 10 years ago, or why are we getting such an increase in data, and then we have that data, we need to do something with it, right? And I didn't hear much about actually acting on all that telemetry.
Yeah, that's my favorite subject, and not really part of this talk, but I did want to lay the groundwork for it. But I think a lot of what we're seeing happen is the stuff that's set up by default in all these cloud native environments. So think of the marketplaces and stuff. I used to work at Red Hat, and when I left, I did a talk in an OpenShift Commons in Dublin, and it was the last talk of the day, and I scared the living hell out of everybody in the audience with, do you realize when you just turn this on with pushing a button in like a Google Marketplace or in an Amazon Marketplace or whatever, there's defaults, right? Things are logging, things are doing stuff. If you don't look, it goes in, it's you're paying for it. It's just running. And everybody's like, I'm a developer. I've done it too. I've done a GitOps thing, right? Syncing the things and all this on a container platform. $800, for a week long of work. And I'm like, what? What? Probably most of it was, I know now, was probably observability data that I didn't even care about, use, or want to know about. One of the things we have in our own platform is a control plane where you can actually physically get a list of what's not being touched at all that's coming into your observability platform, which is like the basic way to get started, right? And it's not that it's completely useless, that you don't ever want to have it, but you don't want to persist it. You want to aggregate that away before you have to pay for the persistence, right? Which is what all the platforms are charging you for. And you just have a switch you can flip on to turn it back on if you decide you need it later. But finding that you're ingesting 300,000 data points and you're able to build the same dashboard you have with only 305 data points, you figure it out. It's not that hard to see the savings you're going to have. So I think there's a lot of it is just the speed of execution that we have to do these days, the hurry up and get there with whatever we're building, and a lot of stuff is just not being touched. It's utterly stunning, I think that's most of it. Another question.
With this, it's interesting with the explosion of data points, though. So OpenTelemetry, how does that factor in, or how does that reduce that, or serve as a filter?
If as you get started with everything, whether it's metrics monitoring or OpenTelemetry, setting it up and understanding that this is there. So like I mentioned, the processors that you can use to filter out stuff you're not doing, you're starting to do that by hand. You're going to see as it scales, that might be fine if you still have time and control over it, but most likely that's going to start getting dropped on the floor. And so you're going to end up having to find someplace a little bit deeper. So one of the things I didn't touch on here is OpenTelemetry does the tracing and the spans, but it can also turn it into metrics, to go into metrics platforms and be viewed as a metric. And when you get stuff like this, then you can hit things like our control plane and then start adjusting the buttons and knobs and deciding what you need and don't need at that phase before you persist it, when you start putting your dashboards together.
I mean, you do this with Grafana, though, too, I think, right?
Same idea, yeah. Your dashboard is a dashboard, right? You're doing a query on the data you have in the data store. So what are you putting in the data store is where you need to look first. You know, you can put it all in if you want, and that works for a while until you explode, you know, until you actually scale. A great example is one of our customers, DoorDash, in the pandemic. You know, that's like here, they have something in the Netherlands called thuisbezorg, home delivery for food. And that went through the roof. And they watched their metrics bill go whoosh, you know, exponentially, in like days, you know, just exponentially grow. And that's complete panic. You can bankrupt your company doing stuff like that. I mean, it's large, born in the cloud, you know, companies. They're cloud native by default, so everything is out there, everything's ready to go. And yeah, I mean, everybody talks about like doing a cap on what your spend is in the cloud, but are you going to turn your company off because it surges? That's not going to happen. That's not how it's set up. That's more for your developers so they don't bankrupt your developer budget. You know what I mean? Nobody cares if you get cut off on Sunday when you're at home messing around with, like I was with GitOps, and I do something wrong and explode the metrics cardinality, and there you go. You know, that's not the idea. Make sense?
Yeah, I mean, sorry, it's a follow-up question though, but the developer shouldn't even be thinking about this. I mean,
right?
Yeah, I mean, this is something that should be done.
Now, these are your platform engineers, your observability teams, your SREs that are fighting with this stuff. That they should be able to. Sorry. FinOps, yeah, very much so. Yeah, they shouldn't even give them the button. They need to make sure that button's not available for the developers.
Open telemetry is just the plumbing, so it won't
Yeah.
solve the fun. Sorry. So what I'm saying is that open telemetry is just the plumbing. It won't solve the issue of the volume. You will still need to employ your own strategy for filtering, for batching, for sampling. I think the metrics, span metrics processor is a great example, because what it takes is that on the 100%, before you even sample, you can calculate metrics off of the trace data to see the classic red metrics, the request rate, the error rate, the duration, and so on. But then again, you then sample and you can send just 0.1% of the actual trace data, the raw trace data, to the backend. So these sorts of trade-offs give you observability without the cost of the volume of the data. So these sorts of strategies, and there's more evolved and more contribute to the community, different processors and different. I was part of the team contributing the span metrics processors. So I'm passionate about that. But the more we have a library of processors like that, then you'll have more freedom to take off the shelf and combine different processors to find your own strategy.
We have time for one more question. So,
just in time.
Perfect. Thank you. Thank you. Are there people that are using OpenTelemetry for auditing? So, kind of, you have an audit log or some kind of set of data you need to have propagated across the stack when you need to check how a certain user is using the software. Is OpenTelemetry the right thing to use, or like? Yeah.
Can we pass the microphone to our expert here? I mean, I can give an answer, but I think you've probably seen more of it than I have. So,
but you're asking like an audit level question as far as like the assurance level of the data?
Yeah, the assurance level, and also kind of, does it make sense? Kind of.
I know what I would say, but we have an expert right here. You start.
The way that I see that, it's less about open telemetry and more about distributed tracing in general. Using distributed tracing not just for the operational side, but for auditing, if I understand your question correctly. So very much so. Actually, I had a very interesting discussion with the creator of Jaeger project. There was also, he shared how they used to do that at Uber back in the day, and that's exactly what they did. We do that also, by the way, in our company. So essentially, it's propagating the data. So for example, if you need to, if you have the user ID or the account ID or the customer entity, you have that on the front end side of things, the top of stack. But usually, when you go down, you propagate down to the bottom, to the transactions on the database. You can map that. And then when you want to understand, and maybe also, by the way, not just for auditing, but also for cost management, for resource planning, you want to see, okay, how much this specific business business unit or this specific product line or this specific customer incurs, so that you can plan the budgeting, cost, resourcing accordingly, you need to propagate this data. And distributed tracing is actually classic for that, because then you propagate all this metadata all the way down to the backend, to the database transactions and so on. So I'm all in favor of this practice
No, I think you nailed it, so I'm going to just leave it there. That's more detailed than I was planning on talking about.
Okay. Well, good.
All right.
Well, thank you, everybody, for attending, and I'm sure you'll be around for questions.
Yeah, absolutely.
So thank you, Eric.
Chat to you. Welcome.
All right. We're 10 past, and up next we have lessons learned with creating platforms on Kubernetes with Mauricio and Salman. So, without any further ado, take it away.
Let's do it.
Thank you very much.
We will probably need our presentation on the screen. That's one thing. There you go. Perfect. So yeah, I think that's kind of like the title. We will be talking about like challenges of building platforms on top of Kubernetes, and we will not make it easy for you folks. We will just be very interactive. You go.
Yes. So morning, everybody. How are we all doing?
Yeah.
Full room. Great.
Let's.
So we're going to talk about building platforms on Kubernetes. There's some experience that we've had working with different organizations, different teams.
Different projects.
Different projects as well. But we are going to focus slightly on machine learning. So if you need to build a platform on machine learning, what kind of things you do. I know because we're going to talk about machine learning, this is now a rule. If you talk about machine learning, you have to mention ChatGPT. If you don't, apparently the presentation doesn't count. So we'll play a game real quick before we get into the real thing. I'm going to present you with two quotes. One is a real quote, and one is a fake quote generated by ChatGPT. And you have to guess which one's true. Are we up for it?
Yeah. Let's do it.
All right, the first one, Donald Trump. People know Donald Trump? All right, let's go with this. So there's two quotes in here. The first one is, sorry, losers and haters, but my IQ is one of the highest, and you all know it, right? So imagine in his own voice. So that's the first one. The second one is, my IQ is so high, it's tremendous. It's like Mount Everest, but with more gold. Which one's real?
One, because he doesn't know where Mount Everest is.
He has a point. He has a point.
Very good point, but...
Yeah.
Which one?
I'm going to say 2 is wrong.
Two? Okay, people think 2. Actually, ChatGPT is better at being Trump than Trump being Trump.
Yeah.
So yes, one is true, the second one is made up. So that's, quite good. Let's do one more. Boris Johnson. People remember this guy? We're from UK, so we both come from UK, so here you go. One more. Let's see which one's...
Great hair.
Yeah, look at that. Good point.
Right, so here you go. This is about Brexit, of course. My friend's Brexit was like a box of chocolates. Nobody knew what we were really getting, but it's scrumptious. That's what he says. And the second one is, my policy on cake is pro having it and pro eating it. So which one is true? One? Well, it fooled us again. The second one is true. So as you can see, ChatGPT is not just being good at Boris, it's actually good at fooling us. But it's not that great sometimes, because I asked it to write a joke. So I said, give me a joke for Kubernetes, right? Because we talk about Kubernetes here. And it says, why did Kubernetes container start a workout routine? Well, it wanted to be in ship shape before it was deployed. You can imagine it's not really a great joke, right? Not a great joke. What do you think? Good, bad? Bad. Let's get one more. Let's see if we can do any better. Give me a joke for Kubernetes. What did the engineer say when asked for reasons to use Kubernetes? 404 not found.
That's worse.
Better? Better or worse? Better? Some people think better or worse? Slightly better. I wrote that joke, so we're gonna pretend that it was AI. But no, that's what this is. But here you go. Let's introduce ourselves.
Let's quickly, okay, my name is Mauricio Salatino. I'm at Salaboy. I'm working for a company that's called Diagrid. We help people run cloud-native applications and scale them up. And the company is heavily invested on a project called Dapper. I'm writing a book titled Platform Engineer on Kubernetes. That's a QR code, and that's my age plus a discount code of 40%, which is really bad. But there you go. I will share that later on Twitter for sure.
Excellent.
You go.
My name is Salman Iqbal. You can find me on Twitter at Salman Iqbal, only because I couldn't get Salman Iqbal on Twitter. I work as a consultant for Appia, as a company for a cloud native consultancy company, and we have a Kubernetes product that makes it easier to use Kubernetes and cloud resources. We are going to be in the sponsor booth, so just check us out in Appia. And I also work as a trainer for Kubernetes. I mainly work on MLOps stuff, so it's just basically DevOps for machine learning, making sure that we can run machine learning workloads and more efficiently. I'm not writing any books, but that's me. If you're wondering, Salaboy and Salman, yes, there's something in common, the first syllable, but yeah, that's us both.
That's pretty much it.
Let's get to the actual bit. We've all seen this. I don't need to explain. If you need to do anything cloud native way, there's a bunch of tools that are available. As you can see, we've all seen this bit. What if you need to do machine learning stuff? what do you have to do? Of course, you can use some of these tools out there, but there is, machine learning has its own landscape. This is done by a company called MLReef, 2021, so you can see it's a couple of years old. If you want to do anything like, let's say, if you want to do CI/CD in machine learning, we can use some tools. There's some tools out there that also help with machine learning. If you need to do modeling, if you need to do training, there's a bunch of tools out there that we can utilize. The problem with this is if we ask, and people here do machine learning or data science, anybody does that? Yeah, okay. You all use ChatGPT, so yeah, we all do it, right? So, if we ask, so we work with data scientists or machine learning engineers, if we ask them to install these tools on any of the resources that they might have, cloud providers, clusters, or whatever it is a big ask. You know, we keep talking about as data scientists and machine learning engineers, learning all of this is quite a lot to ask them. If you ask them to install it in a consistent way, instead of getting something like this, we might end up with something that's installed on the cluster or on the resources, but it's not as nice as we think it should be. It's not as maintainable. It's not as scalable, right? So this is the situation that we can get in. So what can we do? I'm going to pick up on Elon Musk now. Have you seen this podcast? Seen this podcast? If you scroll to like 44.25 and zoom in, the guy's smoking some platform engineering. That's what we need, right? Yeah. So this is exactly what
that's we need. Kind of thing that we
need. We need some platform engineering. So now Salabo is going to take over and talk about platform engineering.
Yeah, exactly. And I think that's pretty much what's going on, right? Like you have different kind of teams building different kind of platforms with different requirements, and you ended up with these situations with clusters filled up with stuff that nobody knows how to configure or how to get working together, right? And we created a project here, like in GitHub, like it's Rejekts EU 2023, where what we are trying to achieve here is to create these different style of platforms with different examples, some for machine learning, some for more like developer-oriented stuff. And then we are starting to try to combine different tools together to accomplish different things. There is like a step-by-step tutorial in there. It's pretty long, and it's pretty complicated on purpose, just to show that this is complicated and not that easy to replicate. So the first thing and the first challenge that you will face, if you are not very mature in your Kubernetes journey, you will need to start learning on how to glue different projects together, and then you will get your hands really, really dirty, right? There is a white paper on platforms that was published very a couple of weeks ago about like platform engineering and like different aspects of different platforms. This is not targeting only Kubernetes, but as you can see, most of the projects that are listed there are kind of like coming from the CNCF space. But in order to build these platforms, you actually, again, need to understand a little bit more about what tools you should be using to bring things together, and then how do you expose all these things that you're installing to your teams, depending what those teams are, right? Like if you have developers, you might give them some developer tools. If you have machine learning people, you probably need to make sure that they can use the tools that they already know how to use. And that includes Python, like a lot of Python. So in the repository that I was showing, we have kind of like a cluster set up with a bunch of tools. And again, because we try to install and configure all these things together, it gets kind of like quite complex. I've been working with Kubernetes for 5 years, and it took me quite a while just to get all this stuff in there. Right? Like it's not that hard, but at the end of the day, if you want to, if you have multiple projects using the same frameworks, but in different versions, it becomes really, really complicated. And then setting up multiple clusters is not something that I would expect someone from ML to do, except like Salman, that he can create clusters. You can create clusters, right?
Yeah, but I'm not an ML person.
Perfect, that's true. So some of the projects that we are using is like, I'm a very big fan of a project that's called Crossplane. How many people here knows Crossplane? Have heard about it? Okay, all the room. Yeah, there you go. That's pretty popular. I don't need to explain that one. bCluster, how many people here knows about bCluster? Okay, a couple. For the ones that doesn't know bCluster, basically what you can do is you can create clusters inside clusters, and that's usually very useful when you have multi-tenant like use cases, and when you need more isolations than namespaces in a cluster. So every time that you create a virtual cluster, you have like a new Kubernetes API server that is completely isolated for the main cluster, and that allows you to give access to teams to these new completely isolated API servers, which is pretty good. So we are using that. I'm using Knative. How many people here knows Knative? Okay, that's a bunch of people. Like, I would tend to focus on Knative serving here because I think that by installing Knative into a Kubernetes cluster, you give like development teams the ability to experiment with their applications, and also you get like auto scaling as well, which includes scaling down to 0 as well, which is pretty important. And interestingly enough, Knative is something that it's been heavily used by a bunch of machine learning projects just to serve models. When you need to expose, like your trained models for other teams to consume, there are tons of projects like Kubeflow and Kserve that are using basically Knative to actually expose these things. And finally, Dapper, that's the project that I'm working on mostly nowadays, which is a distributed application runtime. And again, it gives a bunch of components to application developers to interact with infrastructure without adding dependencies to your applications, which actually it simplifies the development process quite a lot. The idea here is that you can configure these components at the platform level, and then applications can use like local HTTP and gRPC calls to interact with this infrastructure without adding any drivers or libraries to connect to databases or message brokers, or even kind of like use stuff like workflows. So let's do the first demo, which is a very like the weirdest demo that I've done in some long time, which is showing this GitHub repository. And again, this glue things together section. Zoom in a bit. Yeah. All right. Yeah. I can zoom a bit. But the idea here is to show that, OK, you create clusters, you install Crossplane, you install a bunch of other things, you keep configuring things, you install Knative, you install a networking layer, you configure some ingresses, then you install Dapper using Helm, and then you create namespaces, install Argo CD, do some port forwarding so I can access stuff, get secrets, create namespaces, install Redis in a bunch of places, get passwords, configure Argo, install KubeRay and KubeServe just to get something up and running, right? At the end of the day, the only thing that I did is have my Argo CD installation pointing to a Git repository. I can also zoom this. It's pretty simple. But the only thing that this gives me is a cluster with a bunch of namespaces there. Like if I do namespaces, because I like my terminals to be small, but that doesn't fit. I have a bunch of namespaces now with a bunch of software installed. It is kind of working together, but still there are tons of things that we can do better. And if I do, for example, I'm listing just here like the Knative services in production. I have an application that is actually downscaled to 0, so it might take a while to load like the first time, just to bootstrap. But it's just a simple application that is running in my production namespace, right? And that takes us to the next point, right? I spent a bunch of time configuring all these so you can install all these tools in a single cluster. That cluster is usually kind of like a management cluster, right? Because you don't really want to run like Argo CD in the same cluster where you're running your like workloads, like your production Gorlog. So this is like more like a management cluster that it's controlling different things, and it's going to allow me to create different environments. And that takes us to our second point, right?
Yeah.
Which is, yeah.
Based on what Mauricio has just talked about, so this is also based on some of the experience that we've had in building these platforms for some of the machine learning and data scientist teams. When we think about data science, we always think like, oh, we just need some training data, need some test data, let's just train a model and then evaluate and start serving. That's all we think. But I'm sure you've seen this image before, but the reality is much different, because the actual machine learning part is usually okay. You can kind of manage it on you locally, but if you need to scale up, of course, there's another story. There's a ton of other stuff that we now call platform engineering that everybody has to care about. Things like how do you manage your resources? How do you make sure you collect the right data? What's the serving infrastructure? If you serve a model, when you train a model and you serve it, as in people can infer, send requests to it, we need to understand if we can scale up and scale back down when the requirements, when there's a bunch of traffic on there. So all of this is quite a lot. And Eric was mentioning a few minutes ago, developers don't know sometimes. It's happened in the past. Something is logging, and you got like a bill for 20K. What do we expect machine learning and data scientist engineers to know that? So basically, there's a bunch of requirements. And what they do is, if we break down like the machine learning stuff into supervised and unsupervised training. This is an example for a supervised training. Usually you ETL, so extract, transform, and load, get some data in, do some training, do your analysis, and do your predictions, and you keep going over the loop. So the requirement is that what they want to do, if we bring this image back up, data scientists and machine learning engineers, what they want to do is just use their favorite frameworks and libraries, stuff like PyTorch, TensorFlow. That's what they want to use. And what they also want to use is just deploy their model. Once they've trained it, they want to deploy it so people can start using it. Not just people, development teams as well. So this is something that Salabo is going to talk about in a few minutes. Within an organization, you've got data scientists, machine learning engineers that could be training a model, whatever it might be, like cat detection or a model that detects if the text is generated by AI. That's
something coming.
Yeah. And then what you want to also do is serve the model. So these are some of the frameworks. How can we go ahead and utilize these frameworks? Well, there's a few things we can do. If we are using Kubernetes itself, of course, you can always, because most of these are Python frameworks. So if you were doing training, you can build an image and you can do a normal deployment in Kubernetes and just run it how you will. But some of these frameworks, the one that is in here, there's like MXNet and Ray, they usually do is they take the job and they split it and run it on a number of machines. And the way it works, I'm sure people use MXNet. If you haven't, it's like PyTorch, but for deep learning. What you have is kind of like what we have with the Kubernetes architecture. A job can be split over into multiple nodes because something that could take a while takes a shorter amount of time. And what you have is a scheduler and a server, and you have worker nodes. And all of these are actual machines. So virtual machines are physical machines. What we can do with these things is install on the cluster as controllers. If we install on the cluster as controllers, the controllers are already available, and this is what we are going to talk about. Just have a standardized way of installing these tools. Then all of these things become a pod in the cluster. And if all of these things run as a pod in the cluster, we can scale up, we can scale down, and that's great. And we have a standardized way of using it. So you can do MXNet, TensorFlow jobs, you can do Ray. There's another thing that we're going to touch upon later on. We can do that in a standardized way. So in a platform way, we install it on the cluster, and then we can do that. What about when it comes for serving? That's the two things I'm going to focus on. So everybody will come to you, I've got a model that I trained with TensorFlow. I've got a model that I trained with PyTorch. And what you end up with when you have a trained model is just like a file that you stick in a storage somewhere, and people can just send HTTP requests to it, send an image, get a inference back, and say, yeah, your image is a cat or not a cat. If we were to deploy it, you can put it in a storage container anywhere in an S3 bucket, and people can send requests. But the problem with that is sometimes if there's a lot of requests coming in, you can't handle it. So you have to scale up and scale down. And this is where this project called Kserve, part of Kubeflow, with separate kind of comes in quite handy. It says we don't care what framework you use to train your model. As long as you have Kserve, it uses Knative underneath and a bunch of other things, Istio, Kubernetes, as you can see, we're building up. And then you can serve any model, doesn't matter what it is. So that's like what we found was a standardized way of adding your models in and people can use it. So that's from like machine learning point of view. So you can see if you want to do something, this is what we've used. So now Mauricio is going to talk about developers.
So on the developer side, it really depends on your company and what your developers are doing, right? So it's all about like what tools do you need to have in your clusters that you are going to give to developers so they can just do the work that they need to do, right? You need to make sure that whatever you install there, make them more productive, right? So usually the demo that I have here is Knative Dapper. I'm going to add open feature at some point, but again, it's like what capabilities these environments, these Kubernetes clusters need to have for developers to do the stuff that they are doing. And I think that that's a pretty important thing. Just giving Kubernetes clusters to developers will push developers to learn a bunch of stuff. And you can start simplifying that experience by saying, okay, you know, this environment has auto-scaling on. It also has the possibility for you to do different release strategies. And it can also connect to all this available infrastructure that it's already for the application to use, like databases or message brokers or secret stores or whatever. So for this demo, what I wanted to show, it's a little bit about what we did here in the repository. Again, as I mentioned before, we are using Crossplane. And I've created a bunch of Crossplane compositions to create different kind of environments. Let me zoom this up a little bit more. And what I have here is, for example, a resource that it's been managed by Crossplane that allows me to create, in this case, development environments. So I have a very simple CRD here that it's kind environment, and it has a bunch of parameters down the bottom, in this case, just a simple example. And I'm also using labels to define what kind of environment do I want to create. So if a development team needs to request a new environment, the only thing that they need to do is they need to send this request to the platform cluster, in this case, the one that I'm connected with, and new environments will be provisioned for them with all the tools that they need inside that environment. For this demo, I'm using bcluster. So every time that I create a new environment, I'm creating a new virtual cluster inside my platform cluster. But nothing stop us to create new clusters using crossplane in a cloud provider and then installing all these tools. And I have the same thing for like ML, right? So I have the same the same interface. It's nothing different, just the label is different here. So I have a different type of environment there that it's called ML in the label. And that's going to basically get a different composition from crossplane that it's combining different tools together for that kind of environment. Because it's a Kubernetes resource, what I can do is I can do kubectl get environments, and I will be able to have a list of all the available environments that I've created. And as I mentioned before, these environments are, in this case, big clusters that are separate clusters that I can give access to my development teams to access and interact with. If I go back here, let me see. Yeah, so the application here, this is kind of like the thing that I have in my production environment. Hello, rejects. It's really bad. Sorry for the UI. I didn't have enough time to, but this should kind of work. Yeah, so basically it's just storing some strings using a database and Dapper somewhere there. But when I created like this new Team A development environment, as I mentioned before, I have now a new cluster that this is kind of like the interesting part, I would say. It's a new cluster that doesn't have neither Knative or Dapper installed in it. It's actually using some of the new features on the bcluster side to reuse all the tools that I have installed in the host cluster. So if I list the namespaces here in my host cluster, I will see that I have like Knative installed, I have Dapper installed as well, and I have crossplane, right? But I don't want to use crossplane from my development environment, so I will give access only to my Knative installation and also to my Dapper installation. So what I will go and do now is I will connect to this new cluster that I've created, like the development team cluster, and I can do that by running this command here, which is bcluster connect to that cluster. That's called Team A. So I'm connecting to that cluster now. As soon as I'm connected to the new cluster, this is, again, a new API server, so I can get the namespaces here, and there is nothing installed in that cluster, right? So it's a completely separate cluster. But if I list the CRDs, you can see that I have some Knative CRDs already configured and the Dapper CRD for components. So I can actually interact with Dapper components from this cluster without having Dapper installed in this virtual cluster. bcluster is syncing resources from this virtual cluster to the host cluster that has these controllers running, so I can reuse the same installation from that cluster. If I don't do this, what I will need to do is I will need to create bclusters and then install all these frameworks and all these tools in every cluster that I create, and that's basically replicating all the control planes for all the tools multiple times. That's definitely not cost effective. And basically what I can do here is I can list my Knative services again. So I have my application deployed automatically when I created the composition. That's part of the composition. And this basically gives me access to a different instance of the application that now it's running inside the bcluster. And bcluster is handling all the routing, all the traffic to this new instance. And I can say, hello, rejects from here, from dev, right? So this is a different cluster using a different database instance as well than the one that I have in production. So that's why you need to install a bunch of databases in different places. But this is showing basically that you can create like these lightweight development environments that are reusing a bunch of controllers that are installed in a different place. And you can create as many of these as you need for your development teams. You will need, of course, like a large host cluster, but that's a different thing. And that takes me to the next point, I think. Yep.
Yeah. So Mauricio showed you the. Thank you. Mauricio showed you the developer experience of how creating the environment. What also there is when you check out the demo itself, because we don't have time here, check out the repository that Mauricio is sharing. When we create the ML environment, that installs all the CRDs and all the controllers that we need for machine learning. So there is an example in there for one of the frameworks that we picked because that was used, Ray framework, and that also does similar to what MXNet does. you submit a job, and in terms of parallelization, it will take a job and submit it onto the cluster itself and split it out, and all those pods will become worker nodes, and they will run it. The point here is that what we found is data scientists and machine learning engineers do not like YAML files. People like YAML files here? Everyone's laughing. They don't like YAML files, right? Of course, because they're used to writing Python. That's what they're used to writing. They want to write Python. So you can check this out. I don't think we have time to do this demo. So what they want to do is they want to just basically submit their requests like they're doing. Just run their Python scripts. So this is what you can see in the demo itself when you do this. Everything is running in the cluster. We've got this, you can train your scripts, you can train your models by running, they have a CLI called Ray CLI. You can submit your job like you normally would. Or you can run the Python script by using python script.py. If we were to use the approach that we're talking about here, is data scientists and machine learning engineers keep doing what they're doing already. Just write as if they're running stuff locally. So they don't have to like write YAML files, submit the requests to the cluster. This is connected, this Ray CLI is actually connected to the cluster that's running elsewhere. But for them, it's all good, because they're just submitting a job. Granted, you still have to understand if things break, you have to go and look at the pod log and all of this stuff. But here, the developer experience, the machine learning engineers that are using it, is much more akin to what they're used to, rather than, hey, now you got to understand Dapper, now you got to understand this, you got to understand that. It's quite a lot. Mm-hmm. So the final thoughts with all of this is there's a few things that we just want to bring to your attention. Of course, what you saw here, Mauricio showed you all these projects, and the reason why we have to do them, the reason why we had to use them, is because they're all serving a purpose. And I'm sure we all agree, in order to do something quite simple like, okay, maybe not that simple, training a model and serving a model at scale and consistently across teams, across organizations, there's a lot of things we have to install on the cluster. And that's maybe fine, but also all these projects have different release cycles, different versions, compatibility issues. You need to be experts at being able to like build platforms at this level. So it's quite hard. A small organization with a few people might not be able to handle this. You can install, you can get up and running, but we're not at that maturity level that when things break, you actually need to be an expert. Like we were figuring out some Istio issues the other day because it wasn't working. So it's quite hard. Sometimes you might just get away with using cloud services, right? So maybe ML Lab or anything like that. So it's quite a lot, and we're still a bit far away from what we want to get to. So I will leave you with this final thought before I share it. I'm sure you all remember a time when DevOps was big, right? All of this stuff was hard to do in DevOps, correct? Do we all agree? It's kind of hard to do in DevOps. It will hit you in the face. But now we have platform engineering. The outcome is the same. But at least for the next year, it might look cool while you're doing it, right? That's what we're going to say. So that's what we wanted to talk to you about today. Here are some of the links. We can share the slides later on.
Yeah, I will be sharing these links in Twitter. I have some stickers as well. These are a bunch of blog posts showing different collaborations with different projects that basically are we showing here, kind of like in the demo, on how we install everything together. There is a lot about like developer experience in that, and also a bunch of other stuff about like platform building. So if you want to check it out, I will be sharing there in Twitter.
This is just a photo I've put up here. We are at a booth in KubeCon. We got some cool stocks. I'm sure you agree. There's pretty cool beavers there. Yeah, just drop by, say hi.
That's it.
Mauricio's book, buy it. But thank you all.
Thank you very much.
Do you have time for?
So we might have time. We have a 20-minute break, but we might have time for like one question. Otherwise, you can chase them in the hallways.
Let's do one question.
Okay, we got one question there.
Oh, didn't see.
Great.
It's just a quick question, but ideally, what should the developer have to know? I mean, besides doing his or her Python application. I saw that 2-line thing, but that just seems to be too good to be true. So, how does it usually work?
Very, very good question.
I know generally though.
No, this is very good.
3 or 4 people and they're doing everything, but if there were, but in an ideal world, should yeah.
So the question, if I may repeat it just to make sure I got it right, is what do the data scientists and machine learning engineers need to know apart from let's say submit a job in Python. That's all done because of the projects we picked. So in some cases, we might get lucky and say, we have to do just write this. If you're submitting a jobs and using Ray, you're good to go. All you need to do is, I removed a flag which says where the cluster is, where the Ray cluster is running. That's all they need to know. But you don't always get lucky like that. If you need to use kserve to serve the models, you still have to write YAML files. Also, if things go wrong, where do you go and look for it? Luckily in Ray, there's a dashboard that tells you your jobs that are failing. So they can access the dashboard. So in that instance, they don't need to know too much more than where it's running. They look at it and go, oh, this is fine. Everything is as it is. But if you pick other projects, not so lucky. That's why I wanted to show this example.
Yeah.
Yeah, most of the time it stays the same, but in some cases not so lucky. Okay, thank you all for listening.
Yeah. Thank you, folks.
right. At the top of the hour, let's go ahead and get started with why cost optimization does not end with auto-scaling. Manuela and Vanessa, please take it away.
Thank you.
Thank you. Oh, it's working now. Hi, good morning and welcome everyone. I'm very pleased to see you all. And welcome to our talk, Why Cost Optimization Does Not End with Autoscaling. Hopefully my clicker works. Doesn't. Now it does. Quickly introduce ourselves. So my name is Manuela. I'm a FinOps senior consultant at Liquid Reply, and I'm mainly focused on data analysis, scenario analysis, KPI development, and utilization optimization together with DevOps teams in the context of cloud cost efficiency. And this is Vanessa. She is a FinOps manager at Liquid Reply, and she mainly is an evangelist for the topic, developing FinOps strategies together with clients, working together with the FinOps community, and works as a trainer. And we are very pleased to be here today. For the next 25 minutes, we will tell you a bit more about FinOps in the context of Kubernetes. But before we start, could you... Thank you very much. Can we do it manually then? Before we start, we wanted to talk a bit more about why we are here today. And we brought a meme that is very true, because whenever we talk about cost optimization, cloud efficiency, with platform engineers and with everyone who's working in the context of Kubernetes, we get that face. Last year, when we had a talk in Valencia at the KubeCon there, we had like a couple of hundreds people there, and after we finalized our talk, we went back to our booth, we got flooded. There were people coming very enthusiastic, very motivated. They were like super excited about the talk, and then we're like, but you're wrong. We don't need FinOps because we use autoscalers. Our environment is optimized already. And this conversation went on for 2 hours almost. We were discussing, it was kind of like heated by the end of the day. And from that moment on, we kept having these conversations, why FinOps is necessary, even if you have automation, over the last 12 months. So that's why we decided to take all of these prejudices and put them into a talk. So this is basically why we are here today.
But we only have 25 minutes, so we only brought 3 prejudices. The first one is costs are only relevant for the management. And that's actually one thing, we hear that a lot, especially in the FinOps community, that it's super hard to get engineers to do really anything about costs. So that's the first one we will talk about. Second is we are already using autoscalers, and that's enough. Spoiler, it's not. And third one, everything you need to know is on the cloud bill. Let's dive into it. Well, actually, no. Let's recap FinOps for a moment. So FinOps itself, I mean, the one or other might remember the DevOps movement. That was all about bringing Dev and Ops together. And now with FinOps, that's the extension to DevOps. That's about bringing the non-technical people and the DevOps people together. So the idea behind it is we take all of the data that the cloud provider offers, then we make some sense out of the data, we normalize it, take some KPIs, and then we can finally go to the different teams, to business, finance, and the developers, and talk to them on the same level, because we are suddenly acting on the same data, but just discussing maybe slightly different KPIs. And the goal of FinOps is that we increase the business value of the cloud. What that means is we reduce the costs, and with that saved money, we can reinvest the money in something else, hopefully the cloud again. That's the idea. Now we dive into the first prejudice. Costs are only relevant for management, but not for us developers. To start things off, there is a study from Flexera, and it says for every $1 million invested in the cloud, 320K are waste, which means basically like 30% of whatever you have in the cloud is waste, a waste of money, a waste of carbon emissions, a waste of, just plain resources. And to put that into context, so 320K are around 4 developers. So imagine you have now 4 more developers on your team that you can use, that alleviates your pain of working too much, maybe. 320K are also more than 2,000 trees. We looked up a research study, how much a tree costs, to come up with that number, by the way. And that money, the 320K, are also over 50,000 pints of beer. We use the currency of beer here in Amsterdam, so it's not a cheap beer. Yeah, but I think we have to go a bit deeper and look at where does that waste really come from.
Yeah, so 320K is a big number, but to understand why this is relevant for DevOps teams, we have to understand a bit more how waste originates. If you think about how you determine what your container needs, resource specifications come to mind. When it comes to those specifications in Kubernetes, they are optional, so you don't have to specify what your container needs. But if you do, it's up to you. The second thing is, if you think about the Kube scheduler, that one relies on how you determine the needs of your container. Again, it comes back to you, how you specify your resource needs. If you think about how you manage idle resources, again, what to shut down, what to turn off, for how long, and when, is up to you. Yeah, and talking about autoscalers, again, there are 3 different ones. If you think about, and we'll dig a bit deeper into autoscaling in general, there are 3 different ones that are applicable for different use cases, and their efficiency relies on the choice of the autoscaler itself, plus they rely on the specifications as well. So coming back to the prejudice that autoscaling is enough and it doesn't concern you, it starts with your configuration. So that's the whole point. But let's dig a bit into the autoscaling topic itself.
So to recap autoscalers. On this side, we have the horizontal pod autoscalers. The horizontal pod autoscaler checks the actual usage of your pod. In this example, it's like CPU being used. And you have some threshold defined, in that example 70%, and as soon as the actual usage of your pod exceeds that threshold, a new pod is deployed, and so the actual usage is again a bit more balanced. That's the idea of the horizontal pod autoscaler, it just scales out. On the other hand, we have the vertical pod autoscaler, that's also dependent on the actual usage of your pods, but in this case, it just adds more resource to the same pod. So technically, you would use, or in the perfect world, you would use the vertical pod autoscaler just for stateful workloads, and this one for stateless. But practically, you can also mix and match them. And there is a third one, that's the cluster autoscaler. So the cluster autoscaler doesn't look on the actual usage, but on resource minima and maxima that are defined in your pods. And it always checks, okay, how many pods have to be scheduled on the cluster or in the cluster, and checks if there is enough space, enough CPU, memory, whatever, on your nodes. In this case, it's not. We have 3 pods, but just 2 spaces left. So the cluster autoscaler would just spin up a new node, and then it's finally able to schedule the pods, and all good. The theory or the basics so that all of these 3 autoscalers work are actually resource requests and limits. So here the requests and here the limits, and basically the idea is request defines the minimum need, so the minimum requirement that your pod needs. So 200 millicore CPU, for example, and the limit is the maximum, so that's actually the maximum resources that your pod gets, so 250 CPU, to stay with that example. So why is that so relevant, and why is using autoscalers not enough? So with requests and limits, minimum, maximum. The risk is always that the minimum is not set low enough. So in this example, we have just like, I don't know, 60% of the actual minimum being used, which means this space here is waste. And if you click a second time, you see that that's like 30 millicores is just like CPU waste. And now imagine this not having only in one pod, but maybe 3 pods or 5 pods. So that sums up to a huge number of wasted resources. So this means setting those requests in a proper way is even actually more essential maybe than the limits. And you have to iterate over it after some time, after some product development to optimize the requests and limits you set. On a different level, we could also optimize the nodes that are running there. There are like 2 ways you could use instead of the classic on-demand instances of a cloud provider. You could use different purchase options. Secondly, you could also use different processors. So ARM-based ones or AMD-based ones are actually way cheaper and maybe even better in the performance-price ratio. First one, the spot instances. So spot instances are like a different purchase option than on-demand. The idea behind spot is technically that a cloud provider does have some capacity left that is not being used by any other customers at the moment. So they give you that spare capacity for a pricing discount by up to 90%. So you can save up to 90% of the on-demand costs by just using the spot instances. But on the other hand, as soon as there is some other customer paying for the full on-demand price, you have, depending on the cloud provider, 30 seconds up to 2 minutes time until your virtual machine is gone again. So it's a bit risky to go into spots, but it's possible. Talking about Kubernetes and our cluster, we have some essential administrative resources that always need to be there. We might even have some workloads that always need to be running. Especially when we talk about a production environment, we need to have like a minimum machines on there and running or up and running whenever a customer needs it. But we also have that, let's say, optional part, the part that could scale, for example. So here in this example, we have our essential nodes. We have that on demand. We could even go a step further and say we even reserve those instances. That's, again, a different purchase option or purchase model, so that it's safe, so that we always have the critical resources safe and also the critical workloads. We have it safe. There is no worry that no one can take away our machine. But then, on the other hand, we have that part. That's our spot part. So whenever we have like spikes, for example, we could use spot instances. And suddenly we save a lot of costs. Yeah. Secondly, using a different processor. Here on the left side, you see we have 3 different instances, and all of them are the same size. It's actually 2x large, just with different processors. And the interesting part is, when you now look at the right side on the highlighted yellow parts, the price differs a lot. And what you can see is that the Intel processor is the most expensive. So you can save a lot of money if you go like an ARM architecture. In that example, it would be Graviton or an AMD-based processor. But that's also something you need to consider and actively change in your configuration to make it work. And last but not least, storage. That's a funny example. I love that one. We discussed it before. It's interesting because when you have stateful sets spin up a specific amount of pods, just as you defined, and it always attaches a persistent volume to every pod. But then again, when you suddenly scale down the stateful set, the persistent volume is not getting deleted. Can you push the button? Thank you. So what you have is like you have an idle, like an orphan persistent volume that is not being used but is producing costs. So it's just a waste of money. And even like the Kubernetes documentation doesn't say it's necessary to delete a volume. It's pretty interesting. So to reduce costs, you actively need to do something. In this case, delete the persistent volume. Coming to the...
That's important.
Yes. So that was just a short glimpse into the whole configuration topic, why autoscalers is not enough. Having autoscalers, it's nice, but you need to configure the proper resource request limits. And even beyond that, you need to take care of your machines, the size of your machine, the type of your machine and processor, or you could optimize the storage. So these are just like a few possibilities where you can further enhance your environment. And actually the reason why autoscalers itself, it's just not enough.
Yeah, maybe to contextualize this a little bit more, because you said we discussed this with the team. The core of our company is basically platform engineering, mainly on Kubernetes. So we have these conversations with our own team members. It's not that we assume that everyone who's working with Kubernetes is not aware of these topics, but it sums up. You might know that there is a persistent volume, but you are not aware of your, maybe I do a just-in-case adjustment of my resource requests, or maybe you're using the autoscalers, but you are not aware of how iterate scaling or put it into your sprints. So whenever we do these kind of talks, especially in this context, we challenge them with our teammates before. And we have these conversations and discussions also within our team, even if we are one company. Yeah, so we had this morning with like 3 of our engineers. And it was like, yeah, but it says in Kubernetes in documentation, you don't have to take care of it as an administrator. And we were like, yeah, but it produces costs. Which brings us to the third topic, by the way. This is my favorite prejudice. Everything you need to know is on the cloud bill. I have a very short answer to that. It's not. But it sounds so simple, but it's so complex. So I brought an example. What you can see here on the right is a cloud bill. Yes, I'm aware there is, if you go into the different cloud providers' dashboards, you can see cost and usage, which means you get 1 billion line items built per second, which gateway, transit, gigabyte, or whatsoever is stored, but still the key information is allocated per service. We used here AWS as an example, but as you can see, I'm now aware that I paid a couple of €1,000 for a Kubernetes service. What does that say about my costs and how they originate? Absolutely no idea. So when it comes to Kubernetes, we have the responsibility, again, in the tech teams to increase transparency. Even if we might not be the people working with the information by the end of the day, we are the ones who can provide them by adding metadata and integrate monitoring. When it comes to metadata, we can use 2 different kinds. Labeling comes to mind naturally. I mean, the didactics are basically the same as tagging. If you think about the key value pair, you have certain rules that follow up, like limited characteristics of, I think it's 63 by now, certain limitations of what to use. Kube, for example, as a prefix is reserved for everything that comes originated by Kubernetes. But other than that, you are basically free to use it, to put your organizational structure onto system objects in a loosely coupled way. When it comes to cost transparency, it makes sense to use cost-relevant labels. Keys could be something like application, business unit, company, cost center, environment, project, whatsoever. Also important would be that the value description should be comprehensible for someone who is not part of your team, maybe even not IT itself. And here comes the part from the very beginning. We were talking about FinOps as a silo breaker, as a collaborator, as a practice that brings people together. And this is exactly it. Because when it comes to labeling for cost purposes, to increase transparency for cost reasons, you need to invite stakeholders to the conversation that are working with this information. Because otherwise you would not know what label to put, right? Another possibility to increase transparency would be the leveraging namespaces. So from a technical perspective, namespaces are isolating resource groups that cannot see each other's content. But I know it's a very rough explanation, I simplify it. But you can also leverage the information you are providing by giving this space a name, because it works similar to labels when it comes to naming conventions and so on and so forth. So you can use those namespaces to group within a single cluster spent by projects, teams, applications, whatever logic you're using. The key point here is that it doesn't matter if you're using namespaces, labels, or a combination of both, you will need to integrate monitoring to connect the dots. And if you want to introduce cost monitoring, there are different ways. The underlying requirement for all of them is the ability of connecting your performance data, your metadata, and the information from the cloud bill. These are the three components that have to come together, otherwise the cost-performance comparison won't match. So the first possibility you have to do so is to actually use existing tools you already have and extend them. On this example, and I think this is really cool, this is a Grafana dashboard that was optimized for cost purposes. This is highly individual. This matched 100% the needs of the organization that was it built in. The project had every single information they were needed to report on the dashboard right away. That's the big advantage of doing it by yourself. The disadvantage is you have to configure it. It's manual work. It's a lot of effort, and you have to keep maintaining it. So if you are a small company with not many resources, or if you have too many different tools in place, maybe the second option would be interesting for you. There are FinOps tools, a lot of them. The market is flooded. We don't have to talk about that. But generally, the idea is that there are two kinds. One is that you can use FinOps tools that integrate with your existing performance tools. Here's an example. This is a tool called FinOut from an Israeli company, which also will attend the KubeCon. Yeah, they will. And they integrate seamlessly with Datadog. So this is where your performance metrics from your existing tool match with the cloud costs. A third option is to use tools that directly go to the source of information. So your cloud bill and your log files. This is an example, and again, there are many. We're not promoting single ones. There are many. This is Cloudability from Apptio, and they tap directly to AWS CloudWatch files and the cloud bill. This is how they match costs. This could also be an option.
And Apptio will also be on the KubeCon.
Yeah, Apptio will also be on the KubeCon. That's right. All three result in the following. The ability of, here in this example, as you can see, these are namespaces, and you can not only see the utilization and the resulting costs, but you can also see the idle times. So this might help, for example, if you have customers running on your cluster, you can, for example, use that to right size, to provide other T-shirt sizes, if you want to say so. And that's the basic idea of matching those two components to increase transparency. The key message here again is, even if you are not the person using this information, you are the only one being able to provide it.
To sum things up, we had 3 different prejudices. First one, costs are only relevant for management. Well, the answer is no, it's not. And the issue with it is costs, well, technically might be only relevant, but the issue is we as developers, we actually we cost the costs, we allocate the costs, and we are the only ones that are able to optimize the costs. So these are also relevant for us. Plus, when you think about the beer or trees or developers, that could help in your developer life as well. Secondly, autoscalers, I have implemented them, it's enough. Well, it's not. The automation itself only is as good as its configuration, so you need to make sure to give them manual input so that the autoscalers work properly. And third one, everything is on the cloud bill anyway. As you saw, well, it's not, that's a prejudice, because the cloud bill itself, it cannot be allocated to any project, to any product, to any application. We need tags, we need namespaces, and combine that with the right monitoring tools to make sense out of it. The cloud bill itself, it's just a nice overview, but it's not helpful when we talk about optimizing costs. And that's it for today. Do you have any questions?
We do have time for a few questions.
I think there was one over there.
Something that I may want to add from my own experience, I think you're absolutely spot on with it. It's like super difficult to find out where to set my resource request, and that you normally have a lot of ways. That's definitely absolutely correct. What could be used to do this is like the recommendation of the VPA, which is like super helpful to do this. So if you're building a new application, like let it run for a while, and take the recommendation of the VPA and use this to set your resource request. Sorry.
Yeah, absolutely agree. In addition, you could also use load tests before to set that initial resource request in a proper way, and then you can go with the VPA, for example. Yeah.
Well, I would definitely say like mixing the HPA and the VPA, if you're not using custom resource requests, is definitely a bad idea.
Yes,
yeah,
absolutely.
Definitely. You should try that one.
But we saw it in real life.
Yeah.
That happens.
But otherwise, making an educated guess on a new application is basically more or less impossible, because you're always going to be worried about CPU throttling, so you're always going to set it too high, and you're always going to have that problem that you were outlining.
Yes, absolutely
Wasted
agree.
resources.
Yes.
Thanks. Great talk.
Thank you. Thank you.
Thank you.
Anybody else? Good. Well, you can always find it in a hallway track. So, oh wait, behind me.
You didn't see me, so I was lucky. I wanted to ask you if you had the chance to play also with the descheduler. Yesterday there was a talk here talking about this component that basically allows you to, beam pack pods into fewer nodes. Have you ever, used it? What's your experience with it eventually?
Funny enough, I currently have a tab open in my browser with a blog post about the descheduler. So not yet, but yeah.
Good. Well, thank you, Vanessa and Manuela.
Thank you.
Thank you very much. Have a nice day.
All right, with the music transition, we'll go ahead and get started. So up next, we have how to deploy on Friday night. Sounds like a nightmare topic with to most of us. With Thomas, go ahead and take it away.
Yes, so hello, my name is Thomas, and welcome to my talk about how we can deploy something on Friday night. So I'm working in IT for 25 years. I like to install things, I like to deploy things, and I always had the problem that every time I updated something, something broke. Therefore, in the last few years, I did a lot of work in infrastructure automation and also work in the Captain project. Furthermore, I'm tech lead of the CNCF Tech App Delivery, CNCF and CDF ambassador. And if the time is, and if I have enough time, I'm also teaching at the University of Applied Sciences about cloud native things. So what will you hear in the next few hours, I think? I think this should be enough. I will talk about what we as a Captain project learned from the last KubeCon. Furthermore, I will also talk a bit why we all think that GitOps is cool, but which things makes it a bit challenging. Furthermore, how you can measure your deployment strategy. And yes, we always want to know if our application is really working. And in the end, we will catch up, and I will talk about anything which wasn't in the talk. So yes, last year we were at KubeCon at Valencia. We had a lot of traffic on our booth, and what we found out there is currently, obviously, GitOps is the dominant approach to deliver cloud native applications. Okay, so far so good. Furthermore, everyone likes continuous reconciliation in GitHub. So we all like that we can put something in a Git repository, and we have a GitOps controller which takes care of applying this on our cluster. Furthermore, we learned that people would like to get more control in the GitOps processes. So normally, you put something in your GitOps repository, and the GitOps controller applies it. That's his job, and that's what he does. And last thing we learned was that release promotion in GitOps is a major topic. So no one wants to change manifests manually in the Git repository. Anyone wants to automatically do this. And many people are struggling with this. So currently I'm also supervising a master thesis about this. I think you can write books about promoting in GitOps. So after the KubeCon, we put our heads together and thought how we could make this better in GitOps, how we could make GitOps better. And therefore, we started playing around with a new project called the Capital Lifecycle Controller. But at first, let's talk about GitOps and its challenges. So when we are talking about GitOps, we are mainly having a GitOps controller like Argo, Flux, or whatever. This GitOps controller takes a desired state, which is normally stored in a Git repository. This can also be stored somewhere else. And it applies this on a Kubernetes cluster. What we like about this, we have a declarative desired state. So we have our manifest somewhere, we have this stored in a Git repository, and and this is versioned and so on. This is continuously reconciled as I discussed it before. And if the desired state drifts from the Kubernetes cluster, we are aware of that. And the GitOps controller takes care of that, if we allow him to. What we don't like about this is we are always struggling with application and microservice deployment. So normally in a cloud native world, we are always assuming that we have microservices, we have independently tested components, and everything is loosely coupled. But in reality, this looks a bit different. So we have large applications, we have a few services which are tested together, and we want to deploy them together. We are also struggling with scheduled deployments. As I said before, a GitOps controller does what we tell him. So if a manifest is in the Git repository, he applies it. There is no room for scheduling or whatever. Yes, GitOps integration in pipelines is also a very, very funny topic. Think about your integration pipeline ends in the Git repository, and what happens now? So you don't have, you cannot do some promotion afterwards because you always have to do some correlation between the Git repository, between the information in Git, the GitOps controller, and your CI pipeline. And yes, resulting from this, promotion is also a hot topic. So the first thing I want to discuss here is, when is my infrastructure really ready? So when we are deploying something, we want to ensure if our infrastructure is ready, right? So the first thing, do I really want to allow deployments at this point in time? So is there some bug fixing in progress? Is there something I'm working on the cluster before I want to deploy new software on it? Furthermore, are all dependencies fulfilled? So if I deploy an application and this application needs a database or needs a message queuing service and so on from a cloud provider, is this really available before I deploy my application? And one of the third things, are infrastructure changes in progress? So is my Terraform script currently running? Is there already something happening in my cluster? And A second thing, what if I want to deploy a specific set of services? So what I said before, we are not living in a pure microservices world. We might also have problems that we have service 1, 2, 3 in different versions, and these three together are combined into one application. Good. And this is the first thing I want to show you today. What we can do, what our Captain Lifecycle Toolkit can do to help you there. At first, we will apply some Kubernetes manifests. We will check for infrastructure readiness. Therefore, I created a small service which simulates this. This is the readiness service. At some point in time, I will disable the maintenance. Then we will deploy the front end. Furthermore, we will check on the other services. So our application consists of six services. If the front end is ready, and after this is done, then we deploy the backend services. And in the end, we'll see that everything works, hopefully. Okay. So to our demo application. I have a really dumb Kubernetes manifest. So this is the app manifest, sorry. And my screen is very small today. So for the Captain Lifecycle Toolkit, we're taking Kubernetes primitives. So we are doing everything, you can do everything as you did before. The only thing you might want to do is to annotate some things. And therefore, we are taking the recommended Kubernetes labels. So for the detection of an application, workload, and so on, we can take the app Kubernetes IO recommended labels. And for the things which are not more or less standardized, we have created our own labels, such as Captain SH pre-deployment tasks. And we want to check if the front-end service is there before we are deploying other things. And this is things we can do on every workload, such as deployments, stateful sets, daemon sets, and so. A second thing, what we can do to build some kind of application is we can specify such an application. Therefore, we invented yet another application definition. This is called the Captain app. And we specified that this is the application in the version 0.1.1. And this consists of the workloads, potato head left arm, left leg, front end, and so on in these versions. And with this, the Lifecycle Toolkit knows when the application deployment has finished and can take actions after that. And I talked about tasks in the last few minutes. Therefore, we can also define some such pre-deployment tasks in various ways, or pre- or post-deployment tasks. So this is a typical Captain task definition. We can take a TypeScript function which is stored in a Git repository currently. We can pass parameters to it, and this can be executed when it's so far. Okay, and for this demo, we are simply running a pre-deployment infrastructure task. This is also simply running a TypeScript function. This TypeScript function looks like this, and so it will get pretty in the future, but I think it's not so hard to write. The only thing we do is we fetch the URL we passed over via the parameters. But that's enough code. Let's do something. So. Good morning. Okay, so then so this is the Kubernetes cluster where I'm working on at the moment. And what we see here, we are deploying lots of services here. And the first thing we see is that all of our services are pending now, or all of our workloads are pending now. So they are not scheduled at the moment. Furthermore, we see that our application pre-deployment task has started. And if we take a closer look on it, we see that the infrastructure is not ready. Okay, so this is my simple infrastructure service. So the only thing I did here was I'm returning a not ready when the service queries it. And let's say I want to disable this maintenance now. Okay. Sorry, everything is so small here. My port forward broke. Now it's better. Okay, so my infrastructure is in a perfect state now again. And when I get back here, I see that my pre-deployment task has completed now. So the infrastructure is ready now. In a few seconds, hopefully. Yes, the pre-deployment tasks for the other services should start. So we see that the front-end service, should start in a few. Good morning. Yes, so the front-end service is starting now, and all of the other workloads are waiting now until this service is ready. So you see the one container is not ready at the moment, therefore they are still waiting. And yes, on the other side, there are other pre-deployment tasks running which cannot fetch the URL at the moment. So now my pre-deployment task has also finished. My screen is gone. We see that all of the other services are starting now. This takes a bit because of some scheduling things. And in a few seconds, also the last one should be there. Yes, and now all of the services are there, and you can always inspect the state of your application in a Captain Application Version object, which says that the application Potato Head in the version 0.11 is now completely deployed. Perfect. Good. This was the first one. Okay, so now we can deploy an application, we can check for prerequisites, but another thing we always want to know is how successful our deployment strategy really is. So at some point in time, we started working on our platform, we started working on our deployment processes, and the most important things for us technicians is we are always following a business purpose. So we are doing cool stuff. We can create very perfect deployment strategies, but in the end, it's all about selling services, things, or whatever. So a thing we always should have in mind is getting measurable results of our changes in the deployment strategy is instrumental for selling our things. So when we are working hours, weeks, months on our deployment strategy and on our platforms, in the end, everyone will want to get some value out of it. Therefore, we should try to find out how fast we can deploy now, how often we can deploy now, and how happy our customers are in the end. So, and in the end, all of this helps us taking the next steps and selling our deployment, our strategy. So, when, for instance, when we have many unsuccessful deployments, we might want to improve testing before we deploy something. So also in our CI processes. When we have high velocity in bundled deployments and we can deploy each hour and so on, we could consider decoupling and deploy services independently to get a bit faster again, and a bit more independent. And if we have low velocity and many errors, it could be that low velocity is the problem. So when we are thinking of traditional systems, I think we deployed once in a half year. And yes, systems broke, but that's clear because if we deploy with many changes and we don't know what changed when we deploy something, it can get hard to update. Furthermore, it can also get hard to find problems afterwards. So, and this brings me to the second demo. And this was kind of a spoiler. So I will simply deploy a second version of the application. And it didn't really change much in the manifest, so only versions changed. The only thing we see here is that we deploy version 1.0.12 there. And I think my portfolio broke also there. Then let's take this one. Okay, and then we have some really nice dashboards here. So at first, we get some metrics. So you see my deployment is really good. Nothing failed until in the last few hours. But 6 deployments succeeded. 1 is currently in progress. So this is the one I started before. And sometimes we need a higher time frame. And we can also get some metrics out of this. So we can find out how long the version 1.0.0 was there on average. We also see how long it took to transition from 0.1.2 to 0.1.3. We see how long the average time between the 2 deployments was. And we see how long our versions took in average to deploy. And for some people, it might also get interesting when we had application deployments. And this is always referring to the whole application, not to a workload. And another thing we might want to have if we engineer our deployment process. Sorry, everything is really small here. We can inspect all of the things we've done with our application deployment in a trace. So we see that we see how long the whole application deployment took us. So in this case, it was very long. We see how long our pre-deployment tasks took and what our pre-deployment tasks were. So for instance, we waited 5 seconds until our infrastructure check was ready. We see how long all of our workloads took to deploy afterwards. So here. And you also see this for each service, and you see the pre-deployment, deployment, and post-deployment tasks for each service or each workload. So I think with this we can do a lot of funny things and it's easier to find out what's really going on. In the end, we can also take a look at each thing. We get some events back, but at some yes, we only see that it's finished and so on, but we can also pass over more information. All of the things you are seeing here are based on open source software. So this is all done with OpenTelemetry. In this case, it's Jaeger and Prometheus in the backend. it's really easy to create other providers. Currently, there are providers for Dynatrace and Datadog. And with all of this telemetry data can also be used for other things. So yes, you can dashboard it wherever you want. Okay. So we get to the third part. Is my application really working? So we see that all of our pods are running. Sounds really promising. We also see that all of our services are there. It's also a very, very cool thing. But this is what the customer sees. So it can be that all of our pods are running perfectly fine, our health checks are all okay, and everything is fine. But in the end, our application is not really working. So what can go wrong, and what has gone wrong here? We could have performance problems in the application. So we have deployed everything. Technically, everything is fine, but our customer surfs on the website, and it takes him about a minute to load. Therefore, I think this is not acceptable for the customer, and therefore we have to do something. Secondly, we could have functional problems. So we could have missing components in the application, such as a database, and this is not reflected in health checks and so on. Which brings me to the third thing. Many health checks also only pass back status okay. So they don't check if the backend services are there, if the application is really running, and so on. And last but not least, yes, health checks are working based on individual services. So it can be that we have an application with 20 services. Every service is fine on its own, but the communication between all of them is poor. Okay, so how can we know that our application is working? So we have in our lifecycle toolkit 3 phases. The first is the pre-deployment phase. This was the one we saw in the first demo. We can do such things as preparing our infrastructure, checking infrastructure things, but we could also evaluate metrics. So this is also a core functionality which we will not demo today. We can always evaluate metrics there. The second thing is we are deploying workloads. Perfect, this is also a thing we did today. The third thing we will see afterwards, we can do post-deployment tasks, such as running tests, doing notifications, and evaluating metrics. But we can also do this for each and every workload. So each and every workload has a pre-deployment phase, a deployment phase, and a post-deployment phase. So what we did before was we checked if our infrastructure is ready on an application level. We also checked for some services if the infrastructure was ready on a workload level. We also checked if another service was there on a workload level, deployed this workload, did no post-deployment in our case, and then this is the last thing you will see today. We can do some post-deployment things on the application base, and this was the reason why our application object is so important, because given the things we have in the application object, we find out when all of the workloads are deployed. Okay, and this is the last demo I will show you. So we will simply apply a manifest. We will have a new service. This will also check for readiness. This will query the readiness service. We will deploy the new service. We will check for problems using KDS-GPT. So this is an open source project to check if Kubernetes deployments are running, and send the results to the readiness service and give this out. Hopefully this will go really fast. So I deployed a third version. I added a new post-deployment task in the app manifest. you can also see here in the kept app version object what's happening. So we see that pre-deployment evaluations are running. We see now that the app deployment is running. This should also go very fast. We see that a new service is pending. Now the post-deployment task should come up shortly. Hours later. So this is running and completed. So we see that KateGPT has been triggered. And in the end, I said I want to notify some service. And this was what I did here. And I see I have a new event there. So this was only a simple service I created. And if I mouse over, and this is a thing you don't see, is that KateGPT found no problems. Perfect. Okay, to wrap this up, how can we deploy it Friday night? We should know our application and get insights. So every time we build an application, we should try to find out what can we check before we want to deploy it, what do we have to prepare, and what can we evaluate. We can make improvement based on telemetry data. So if we find out that something takes too long, we can find out which workload was it and so on. We can check our readiness before deployment. So we checked if the infrastructure was ready, and after that we deployed it. And we can run validation steps after deployment, as we saw here with KateGPT. Okay, what would be really cool? It would be really cool if you would also contribute. So we have a lot of Captain enhancement proposals. We have a lot of cool people, lot of cool features in the pipeline. But everything would go faster if we were more. Furthermore, you can write simple Captain Lifecycle Toolkit tasks. So everything I did with the KateGPT integration, with sending HTTP requests and so on, these were things I did in the last 2 days. So I think everyone is able to write at least some TypeScript function. And if you are doing much, if you are contributing very much, you can get a rockstar. So we are also we have Captain Community Rockstars. These two were really good contributors. One of them is also a TC member now. And we are a really nice community, so just feel free to come to the community meetings and so on. You can get in touch with us. Link and stars on our repository. So I think we are about 30 people now. I hope I have 30 stars more in the next 1 hour. You can also always share your thoughts. You can ping us on the CNCF Slack, and you can always raise PRs, meet us on Slack, and so on. Okay, this was it from my side. I think this was on point.
I mean, and so this is the last talk before lunch, so questions are welcome. You're just eating into your own lunchtime, so otherwise. We can give a hand for Thomas and then maybe take some questions.
Thank you.
Anybody?
And you can meet me and other Captain people on the booth at KubeCon.
Very good. Thank you, Thomas.
Thank you.
We don't know how to.
Just waiting for the slides.
I'm guessing they flip the switch.
Awesome. Cool. I think we can get started then. So thank you all for coming. Me and Winner are going to be talking today about building internal platforms on multi-cluster Kubernetes. So before we get started, I think I want to give a brief history around how we got to internal platforms today and platform engineering as a whole. So as many of you are probably familiar with, way back when there used to be the separation of dev and ops. So you'd have your developer teams writing code and throwing it over the wall to the operations teams, who would then package it, ship it, deploy it, and operate it. And this caused a lot of friction. I think it's really well documented, all the pains that this method had, low release cycles, very buggy software, and just overall not a great experience. So that saw the rise of DevOps. So all of a sudden, application teams are working collaboratively with the operation teams throughout the entire process. So they were making sure that they were always working together to build, test, ship, and operate the software. And I think everybody generally agrees that this has led to quite a good outcome. You know, the software is more reliable, it's getting released more frequently, and just overall there's less friction within the organization. But with this, every application team has had to have a bit of a higher cognitive load. All of a sudden, the application teams are starting to have to manage all the services that they need in order to test and build their applications. So an application team might now need a CI/CD, for example. They might need a database. They might need a cache. All these different services they need to go about their day-to-day lives of developing the application. And when you have an organization with tens or hundreds of application teams, what you end up with is all these application teams doing a lot of duplication of effort, right? You might have 10, 20 teams that all need the same CI/CD, or they all need a Redis or a Postgres, and they all have to go figure out how to do that themselves. So what that's led to is the rise of platform engineering teams. So platform engineering teams go by many names in many organizations. A lot of organizations might not realize they have platform engineering teams, but any team that's there to help reduce the cognitive load for the application teams is essentially a platform team. So in the simplest scenario, it might be a platform team that just manage a centralized CI/CD system, and then every application team can come and use that CI/CD system. Or it might be a GitHub repository that contains a set of Terraform templates that all of the teams can use. Or it could be more advanced. It could be something like a platform team that can create developer environments for you that are pre-provisioned with some services that you might need. And overall, it's been a really valuable way of reducing the cognitive load for the application developers. So what I'm going to talk about is a few trends of how we've seen people do platform engineering in the industry. The first one I want to talk about is the tickets-based approach. So this might be a scenario where in your organization, the application teams might go to the platform team, fill out a ticket. It could be on Jira, it could be a GitHub issue, it could be any sort of form around what they need from their platform team. So I need a Redis for this configuration, or I just need a Postgres or a CI/CD or whatever. And the platform team will take that request, manually take it, read it, fulfill it, maybe have a bit of back and forth conversation with the application teams. And while what the application teams are getting back is a highly customized set of services that they have been able to put their footprint on it, and the platform team has also been able to put their footprint on it as well. Maybe they care about the governance and security of what's getting deployed, making sure it's all up to date. It's quite a slow process, right? You're going back and forth between two humans. It's not on demand. It's not self-service. It's quite a slow turnaround. So there's a lot of drawbacks to this approach. Another approach we see quite a lot is just handing application teams cloud accounts. So you might just say, here's the credentials to GCP. Go get all the services that you need. And from an application team's point of view, this is nice in that I can immediately get whatever I need whenever I need it. I can just go to the cloud and provision an RDS if I need a database. But all of a sudden, these databases and these services that I'm provisioning in the cloud aren't customized for my organization's needs. And the platform team has no way of making sure that you're being compliant with things like security standards or all the other concerns they might have. So another common approach we see is just handing application teams Kubernetes clusters. It could be a namespace, it could be a whole cluster, and just saying, here you go, use Kubernetes, just deploy all the services you need on that. And while this is nice because the Kubernetes API is a pretty good and consistent experience, it hasn't really addressed the problem. You're still having all your application teams go to Kubernetes and deploy the stack for all the stuff they need for testing, or everything they need for their DevOps lifecycle, and it's just basically just reducing the scope of how they're deploying their services. That's all it's really doing. And finally, we see a lot of templates being handed down from the platform team to the application team. So this could be Terraform templates, it could be Helm charts, it could be Bash scripts. And this is nice in the sense that the platform team can write something that is customized, could be quite high level, and they just hand it over to them. And they know that from the platform team's point of view, I've got my business organization needs embodied in those templates. So like in Terraform, it could be I have the right files, my database, all this sort of stuff. But now you're sort of back to the reverse of the dev and ops that we had in the first place, where now the platform team is writing some templates and handing it over to the application teams to run and operate it. So we're still going to have all the pains we had in that world, and it doesn't really necessarily solve it. So what you really want is the best of all of these four scenarios. You want a platform that is customized for your organization, so the platform team can put in their organizational needs into the requests. You want it to be on-demand and self-service. I want to be able, as an application team, get what I need when I want it. I want to be able to consume it via a clean and consistent API. And I want what I consume to be through a high-level API. You know, a lot of people don't want to say, I want a Redis, and here's the configuration for that Redis. They might just say, just give me a Redis. I don't really care how it's configured. So this has led to, so in order to have all of these four together, what we think you need, and a lot of people are talking about nowadays, is a platform API. So this is a single API that your platform team will build and manage, that your application teams can then go to consume these services. So the application team can come to this platform API and say, hey, I need a Postgres, make an API call to the platform, and then the platform can go about fulfilling that request. Now, you might say this sounds all really good and easy, but there's a reason people aren't doing this, because it's quite difficult, and that's true, which is why at Syntasta we're working on a framework called Kratix, which is a framework for building platforms, and we think that this makes it easier to achieve these four goals. So I'm going to hand it over to Winner, who's going to talk through a demo of using Kratix.
Thanks, Jake. So we're going to show a quick demo of Kratix and a platform API and how to get off the ground quickly. We have a organization that I'm going to work an example through with you. And in this organization, we do have a platform team and we have application teams. And one of these application teams has come to the platform team and said, help, I have an application to deploy, but I need to decide about serving. I have some data requirements, and I need to make sure that I can manage cache. And so in this organization, working together with the platform team, they land on Nginx for the serving, they enable Postgres, and they decide on Redis for cache. Now, using Kratix as a framework and a foundation for that platform API, you take the services that your application teams are needing and you encapsulate them in what we call a promise. So a promise is taking that service, bundling it together and saying, I promise you that if you request it, the platform will provide you these services. So in this case, if you have an application team that needs these three services, then these Kratix promises could deliver those services once the requests come into the platform API. But as we talked about in terms of value and reducing cognitive load, as a platform team with Kratix, we can go sort of one step further, where we say, actually, what you need is an environment, much less than you need those individual bits. And how can we enable you more quickly to go from nothing to actually having a running environment where each of those three pieces is wired together and includes any business context you may have and is operational. So instead of making three individual requests that then get returned and have to be wired together, Kratix allows you to define a higher level promise that includes those lower level concerns and how to configure each one respectively. So if we think about modern application teams, though, they're not just going to have one environment, they're going to have two to many. For example, a development environment and a production environment. And so you could write a development promise, and you could write a production promise, and you could have the teams make requests for those, or you can take it one step further. So in addition to environments, teams for that full development lifecycle will need tools around observing the system once they start putting the system in place, and tools around automating the stuff that they don't care about because they want to ship features and focus on customers. So you can author observability promise, which includes metrics and dashboards. You can author pipeline promise, and you can swap in any sort of technologies here that seem appropriate for the organization. You can take that higher level idea and say, actually, you need a full app as a service. So with a single request, an application team can ask the platform API for an application as a service, and they would then get back access to a development environment configured and ready to go, production environment, and then either space or their own provisioned observability tools and pipelines. So the other element to many platform engineering teams in organizations is that they have their customers, the application teams, which they want to keep happy, and they want to keep making sure that they adopt the platform and use it over time. But they also have many, many stakeholders, and those stakeholders have very important concerns for the business. And what we've seen is that sort of off-the-shelf platform tools tend to make it very, very difficult to insinuate business requirements into the offerings that you're giving your teams. And so with Cradix, we take the approach that every promise needs to have the capability to define and integrate business requirements. So in this organization, they've landed on consolidated secrets management through a shared vault where teams get namespaced spots for their applications. And they've also, as an early step in their compliance, they trigger a Slack notification when an environment is requested. So again, this pipeline enables the sort of full business to have higher trust and confidence that the applications that are being deployed are deployed the right way in the safest way possible. So now we're going to attempt a demo. We're going to be running multi-cluster Kubernetes local on my machine using Kind in Docker. So pairing this app as a service promise down a bit, it's going to trigger a Slack notification when the request comes in. And it's also going to create instances of Nginx, Postgres, and Redis to deploy an application that the application team has defined. So let's see how this goes. So again, this is what we're going to be deploying. So we have, I've set up some clusters. We have a platform cluster, which is where the platform API will live, and then we have a worker cluster, which is where those workloads that the platform requests will be created. And right now, as I mentioned, Cradix is based on the concept of promises, so the platform is built up of promise offerings. Right now, hopefully no surprise, we don't have any. This is a fresh system. But when you define your promise YAML, you apply it to the platform in a very Kubernetes native way. This shouldn't really surprise anybody. And when you apply it, then Cradix and the platform understand what you're trying to offer, and they then register that new promise. Earlier, we spoke about those lower-level promises building up to that higher-level experience. And so if we do another request after a minute, what you'll see is that actually those lower-level promises, if you choose, and in this case we did, can be exposed as additional promises. So that escape hatch for teams that don't want all in one, but instead they just want an Nginx or they just want a Redis, Cradix makes it easy to have those lower-level promises exposed as well. So we have all of the promises installed. We have the CRD ready. So when that application team goes to request their app as a service, the platform is ready. And so speaking of the request, so Cradix has the concept of a resource request, which again is very familiar for Kubernetes folks. Resource requests in Cradix can be as simple or as complicated as you want them to be. We tend to err on the side of simplicity because we want, again, to reduce the cognitive load. And in this scenario, what we're saying is that the application teams need to tell us a name, and they need to tell us where their application code lives. And then we have exposed database functionality. And really, the reason you have that sort of lower-level question there is so that in the future, your pipeline can switch on what database you want, depending on what the request comes in for. So right now, we are configured to give Postgres every time, but it's fairly straightforward to do a switch and then offer MySQL instead of Postgres, for example, or to offer different offerings depending on the environment and the team. So again, applying the resource request straight to the platform, and we can see that Kubernetes and Kratix understands that request because we can see the resource is now pending once the request comes in. And for resource requests, again, as I said when I mentioned the pipeline, and in general with those lower level promises, as soon as a resource request comes in, the promise pipeline kicks off. So if we look at the pods on the platform, it's a bit hard to read, I apologize, but you will see that there is a request pipeline defined for each one of the promises, the higher level and each of those lower level. And so if I flip back to the slides for just a second, I'll show you that the request came into the platform as that single request, and then internally what happens is the pipeline runs, there's a Slack notification that we'll check for in a minute, and then additional requests for the lower level promises get created and dumped into a GitOps repository. That repository is, of course, syncing as well to your workload worker clusters, and that's how the system works at a really high level. So if we go back to our demo and look at our worker cluster now, you can see that we have all of the services that the application team requested. So up and running, we have a Postgres, we have Nginx, we have down at the bottom the actual to-do application, very high customer value here. And you'll see some operators as well. We won't get into that today, but that's part of installing the promise, is enabling those worker clusters to have the resources it needs at installation time to be able to fulfill the requests that come in. So now theoretically, I have a hint to help me remember where this application is. And if we click into the browser, we will see a to-do application, and this application is wired up with persistence and ready to go. So at a really high level, that is a very simple demo with Kratix, and now Jake is going to talk a little bit more about what Kratix can do.
Awesome. Thank you, Wenna. So the first thing I want to talk about is multi-cluster scheduling. So we talked about this promise as a whole having lots of different components. We talked about it needing CI/CD, observability, and obviously the different services that you need across your different environments. Most companies nowadays are doing multi-cluster. There are loads of great reasons why you'd want to separate out stuff across clusters. Maybe it's security concerns. You don't want certain applications both co-located on the same clusters. Maybe it's concerns around availability. You know, if a particular AZ in the cloud goes down, you want to make sure that your application is still working, so you might deploy it across different regions or different availability zones. And just overall, most people we talk to nowadays are all aboard doing multi-cluster Kubernetes. So if we take a look at what might be a reasonable layout for the stack that we talked about so far. So you can imagine that you want one centralized set of observability tools, like you want one place where you can go for your Grafana and your CI/CD, so like on the platform cluster, for example. And then you want your individual dev and prod environments spread out across different clusters. You don't want to co-locate them on the same cluster. So doing this in Kratix is quite easy. So Kratix has this concept of clusters. And when you register a cluster of Kratix, you give it some labels to describe what is this cluster for. So in this example, we have 3 clusters. We have a platform cluster, a dev cluster, and a prod cluster. And they're all labeled with that environment tag associating them. And then, because these are just labels, you can use as many labels as you want. So for example, for the production cluster, you might add the PCI equals true label. And what happens is, like when I mentioned earlier, when a pipeline fires off, it's the pipeline's opportunity to decide, based upon the inputs, where should I schedule this workload? So it might be, for example, it could be that your resource request says it as an argument, like dev or prod, in which case you know, OK, when I output these resources, I'm going to tell Kratix, only schedule it to clusters labeled dev or labeled prod. It could also be much lower level. It could be that they happen to ask for Postgres. Therefore, you need to know that you need to use a cluster that has data volumes configured to have like backups enabled. So maybe you would add a label to one of your clusters to say, hey, this cluster is a dev cluster, but it's also got backups enabled. So you might do like backups true or something. So the power of it is that you can add whatever label you need for your context. So it could be also that maybe you're just adding team labels. So you might have a particular cluster per team, in which case it might be nvis dev, and it might also be team A as another label. But Kratix is all around making it easy to schedule workloads to various different clusters. So we talked about a lot of promises today. There's a lot of software here, Nginx, Postgres, Redis, Prometheus. So the prospect of taking all of this and then converting it to promises and using it in Kratix might sound a bit daunting. But we've been working on a marketplace of promises. So if you go to kratix.io/marketplaces, this just links to an open source GitHub repository where all these promises exist. This is all Apache 2 open source. The marketplace consists of a bunch of promises that we've written, as well as with some we've had contributed back from the community. So, for example, Maurizio here from the Dapper community contributed a Dapper promise to the marketplace. And we're always looking for new contributors as well. It's just a great place to go and enable you to get started very quickly with Kratix and promises. So as Winner did in the demo, we made a resource request to the platform using a Kubernetes manifest. And within your organization, your application teams might be used to this. They might be really familiar with Kubernetes and writing YAML, in which case this process might seem really easy for them. You might have other teams in your organization that don't use Kubernetes or just really hate writing YAML. And the power of Kratix is that because it's just using the Kubernetes API under the hood, anything that you can use as a front end for Kubernetes, you can use for Kratix. So, for example, Backstage is a really popular way of building platforms and integrating with Kubernetes. And Kratix comes out. Kratix has support for Backstage built into it, and we have a great blog on our website if you want to check it out of how to use it. But really, anything at all can be used as a way of integrating on top of Kratix, because it's all just the Kubernetes API under the hood. And lastly, I want to talk about composability again. So like Winner mentioned, when we take this sort of bigger app as a service promise, these are all individual promises underneath it. And we could see that in the demo that she did. But it might be that different teams have different requirements. So I can imagine a world in which all the teams need CI/CD and dashboards, and they want to make sure they're using Vault and that they're doing all the things that their business needs need. But they might have different requirements for databases or for serving or for caches. And because these are all made up, all the promises are made up of lower level promises, it's really easy to just take one of the promises and swap it out for a different one. And because of pipelines, you can put the logic in there. So you could say, oh, they haven't specified for a Postgres, they said a MySQL, I'm just going to swap out the promise that I'm making a resource call to. So it makes composing sort of different experiences on Kratix really easy. So what next? So if you are interested in Kratix and learning more, you can go to kratix.io. We have a great set of docs and getting started guides. And Kratix is also hosted on GitHub. It's an open source repository. We're always looking for feedback and contributions. PRs and issues are always welcome. It's all open source, Apache 2.0 license. And yeah, we'd love to have your thoughts on the product. And if you don't want to type links in, you can scan this QR code and it will send you straight there. So yeah, thank you.
Thanks, Jake and Winner. Any questions?
Thank you for the talk and nice solution. I have a question regarding what you showed. Is basically deploying the services inside Kubernetes. What about managed service from the cloud providers? Do you have in your vision like combining with something like Crossplane and also spinning up resources out of Kubernetes?
That's a really great question. So that comes up a lot, and we actually have a blog on our website about using Kratix and Crossplane together. Because like you said, Crossplane is a great open source tool for provisioning and managing resources in the cloud. And it actually fits in really nicely with Kratix. So just like we had a shared CI/CD, maybe you'll have a shared Crossplane instance that you'll use to provision and manage all your cloud services. So it just integrates together really nicely. But even if you're not ready to use a tool like Crossplane, because every resource request runs a pipeline, you can put any logic in there that you need to. So maybe you want to run Terraform applies, maybe you're using some other CLI to provision resources. You can just take what you have today, put it in there, and it should just work.
Thanks, Jake. Any other questions?
Hey there. How do you implement a promise?
That is a great question. So we have a lot of, without getting into too much detail right now, if you go to our docs site, we have sort of a set of references, but then we also have a set of guides. And the guides go from 0 to writing a promise, writing multiple promises, changing promises. We're working on building out a set of foundational promises in the marketplace, which you can fork and change as you need for your business context. But the steps for writing the pieces that are required for that promise definition are in the guides on our docs. We essentially define a few high-level properties that Craddox looks for internally to be able to do the Kubernetes registering under the hood, to be able to understand the pipeline, to be able to, at this point, it's a fairly simple API at every level, and you just have to follow through and make sure you've got the pieces that you need.
Thanks, Mina.
Maybe as a follow-up on the previous question, let's say I don't want to run a Kafka cluster for every customer or every whatever running on the Kubernetes. So could I make a promise that sort of adds a new whatever, something, a host, or an instance, or a new queue, or whatever? So not a complete new Kafka cluster. Would that be possible?
Yeah, so there's that question around like slices versus pies. So don't want to get a whole new database, but give me a slice of that database that's already existing. Absolutely, yes. Yeah, so that's one of the core ways we see application teams and organizations accessing things, whether it's a shared vault instance that's across the organization or queues in a shared Kafka. Yeah, there are ways to do that.
Thanks, Mina. Any other questions? Thanks so much, Jake and Mina.
Thank you.
Thank you.
All right, next we have John Keats from Wacamp to talk about proxy WASM. With Istio is half-baked, but works great. Thanks, John.
All right, let's see. Got to make sure that this is tricky. Yep, almost. There we go. And let me do presenter view in here. All right. Does the clicky click thing work? Yes, excellent. So, hello, everyone. Small audience, but that's fine. My name is John. I will do a quick introduction, so you have some context as to why we're using proxy WASM at all and how we got to using that as a solution to our problem. We'll work our way through the problem context, through Istio a little bit, just in case you don't know what Istio is, and then towards proxy WASM. And if there's any room at the end, then we might have some Q&A if someone has questions. So, first a little bit about me. I've been around in the technology world for a while, and I've been doing everything inside of software, hardware, whatever you can imagine. I started as sysops and sysadmin stuff, but at some point you want more. Before you know it, you're doing software engineering, architecture, and at some point you end up at Wacamp doing microservices architecture, which is pretty cool. And if you need to find me later on, I'm at John Keats pretty much everywhere. So, Wacamp is an e-commerce company. For people in the Netherlands, they will probably know Wacamp. For people outside of the Netherlands, you probably not have any clue what Wacamp is. So I've stolen this slide from our corporate slide deck. There's one thing that's not listed in here, and that's we have quite vertical integration. So we have our own logistics centers, and we have our own software engineering teams and our own infrastructure engineering teams. So I've been told that for, well, a Dutch-sized company, that's somewhat unusual, but it works pretty great for us. Wacamp has been around for a bit. This is also just a copy from our corporate deck. But while this is what the outside world sees, if we look at it from a technology history, then we started with a bunch of non-technology because, well, it's the 50s, so what you're going to do? There's not much technology. But you scale up your business, and at some point you will need technology, such as punch cards, which go into these machines, which are mainframes. And from that point forward, because this was, of course, the hot new technology back then, it will at some point become legacy. Now, this was around the 70s somewhere, so of course it's legacy. But legacy is also what caused us to look for something to fix a very specific problem in our traffic management. And yeah, that's where the problem arises. So right now we are moving from Mesos to Kubernetes. We have a Mesos-based platform that's been around since about 2014. It's all custom because at that stage there wasn't any publicly available technology to do what we needed to do. And while that has served us well, it's kind of getting old. It's hard to maintain. The Apache Software Foundation at some point was like, well, maybe we'll put your software in the attic so it doesn't get any software updates, security updates, anything like that anymore. So that would be somewhat scary for us. So we wanted to move to Kubernetes, but we didn't want to essentially say, hey, business, you have to go in a feature freeze for a year and we're going to build something new. That's not realistic. And what we did is we talked to a bunch of people and we came up with a bunch of rules. For example, everything that currently works needs to keep working. So both on the old platform and the new platform. That also means that when a developer delivers their CI results, which is usually a Docker image, we need to still be able to ingest that. And then the platform has to make sure that your service, when deployed, is actually reachable. So those are pretty important rules, because if you don't, then, well, everyone's going to be very sad or very mad. Now, the other rules are don't make anything worse, which is more like a quality control and scope creep control rule. It means that it's okay to port something over that's not super nice. For example, plain text credentials in GitHub repositories, which everyone has done at least once in their lifetime. But if you try to fix everything at once, then your project will never end. It's kind of like the inverse of what it says there, but that's the rule that we've written down because that sounds a whole better if you're presenting it to management. And then the last one is also very important. Don't make everyone rewrite their code. So what we also can do is we are not the largest company in the world, but we have about 350 microservices. And what we can do is ask all the teams, hey, all that code that you ever produced, make sure that it works on the new platform as well. That's not something that we can ask of them. we don't have the manpower, and we don't have the money. So, with these rules in mind, we figured out, well, and this is about the traffic part, so we don't have to like take a 5-hour walk about all the other things that you do in your platform. But we essentially went shopping for a replacement for our traffic part. So we didn't have that much experience in Kubernetes and the cloud native sphere and all the projects that are around. So we essentially found Istio after a little bit of searching and testing. Now, if we look at the legacy traffic, which is what we have to keep alive essentially, we have a somewhat normal flow. I mean, your browser goes to Cloudflare, Cloudflare goes to a load balancer in AWS, and it then goes into OpenResty. And OpenResty is essentially Nginx with a whole bunch of Lua in it. Well, we only have one Lua developer, and this was built before my time, but I'm also the only one who can apparently maintain it. So that's risky and problematic. But that OpenResty gateway does a whole bunch of important stuff, and then it forwards it to HA proxy, which again gets its feed of what services exist and where they exist in a custom manner. It's also not great because, well, who gets to maintain that? We do. And it doesn't add any the reason why you maintain something is because it adds value, like to your team, to your business. But this, I mean, now, this is standard. Service discovery, pretty much every package has that. So the reason that we're doing that custom still is because, well, in 2012, 2014, there was no other way. This was the way. So we need to make sure that these custom things, that the microservice that receives the traffic doesn't have to change itself in order to keep receiving traffic. So we take what we have in this picture and we turn it into a shopping list. So we know what features we, at the very minimum, need to support. And because this shopping list is just, well, if you sit in a group of people and a whiteboard and you create a shopping list, you get something like this. This is, of course, not something that is going to deliver you any results if you plug it into Google or plug it into the CNCF landscape. So what did we do? We turn it into some more generic terms. And if you take these generic terms and you compare it with what is available in Istio, you get a pretty good match. Now, what is not matched is the authentication layer, and I'll talk about that a little bit, and the self-serve configuration, because our old configuration relied on having a very long Docker label in your image, and that would then get parsed during deployment, and that would contain your traffic configuration, which is so non-standard that nothing ever supports it. But we're going to cheat a little bit because we don't have time to talk about that, so we're going to pretend that that's okay as well. Now, the authentication layer, that's happening between these two parts, so the REST container and the microservice container. So the OpenResty container, it essentially has a job of ingesting traffic, which comes from the outside world, into your cluster. And what it does is it sees like, hey, there's a JSON Web Token coming in. I want to make sure that that is a valid token. And if it is valid, then we're going to extract some information from that token, and we're going to put it in HTTP headers, which means that then your microservice, all it needs to do to know for which customer it needs to serve some response, it just check the headers. Headers contain your customer number, easy peasy. Not very secure, I might add. So this is something that was grown essentially out of habit. But this functionality, exactly as it is pictured here, needs to be re-implemented in Istio. Now, Istio is a very pretty cool traffic mesh system, but this is too custom to do with just pure configuration. So Istio does support JSON Web Tokens, and it does support header manipulation just by using configuration elements. But what it doesn't do is doing it with JSON Web Tokens that are not entirely standard, and with validation methods that are also not entirely standard, because they were old, essentially. So Istio is a service mesh, which means that for every service that you have, you also get an Envoy proxy that's delivered with your service. So the blue box essentially is a Kubernetes pod, and whenever one of those spins up, because you say, well, I want service A, give me a pod. And then the pod starts up, and Istio says, hey, wait a second, I'm seeing a pod appear here. We're going to add a proxy, and we're going to reconfigure your network. So everything your service A and your service B does has to go through the proxy, which means that you can monitor all the traffic, you can manipulate all the traffic, you can reroute, you can do whatever you want. You're essentially the boss of all the traffic. Now, it does a whole bunch of other very cool things, but this is the main part. The proxy can do whatever you want to the traffic. Now, this proxy also lives inside the ingress gateway. So when you use Istio and you want to ingest traffic from the outside world, you use your ingress gateway. And this is a very helpful picture from Banzai Cloud, so I didn't have to make it. And it shows the essentially all the users on the outside, all the services on the inside, and this box where every bit of traffic gets squeezed through. Which means if we want to do anything with the authentication, that's where it needs to happen. Now, what do we use? We use ProxyWasm. Why do we use ProxyWasm? Because the Envoy proxy is written in C++, and we're not very good at that. It has a filter architecture, which is also written in C++, which we are still not very good at. And it comes pre-delivered with a bunch of filters that almost do what we need, but not entirely. But it also has this very special filter called the ProxyWasm filter, which allows you to manipulate your traffic using ProxyWasm. Now, a little bit about ProxyWasm itself. There have been a bunch of talks about WASM. So very quickly, it's essentially a Flash player, but better. It is in your browser. At least that was the start of it. So you run binary programs in your browser. It sounds a bit like Java applets, but it's better, I promise. And instead of doing it in a JavaScript runtime or scripting engine, it's running inside of a virtual machine. And that also means that you can essentially use any language that you can compile into WebAssembly bytecode can run inside that virtual machine, which is pretty great. It means that instead of having one language and you have to transpile it, for example, TypeScript to JavaScript, you don't have to do that. You just use whatever language you want, as long as it supports compiling to bytecode. Now, and it is very fast, so of course someone had to do it. You take DOSBox, you recompile it into WebAssembly, and then you run your WebAssembly DOSBox in the browser, and then you install Windows 95 inside your browser, which is possible. It's not super useful, but it should give you an idea that it's very fast and very performant and very capable. Now, if we look at the proxy part of ProxyWasm, it is essentially an ABI, so an application binary interface, which means that as long as you adhere to the standard, you can use this specification. So on the Envoy side, you have the WASM filter, which implements the host side, sort of virtual machine with the API that you need in order to use these modules. And on the module side, you have to use WebAssembly, but just not random WebAssembly. You need to need specifically ProxyWasm API-compatible WebAssembly, which is slightly different. And that comes back to bite us in the ass, so we'll get to that as well. Now, what happens is that your filter or your proxy starts up, it loads its configuration for all its filters, and you have many filters in theory, and one of the filters might be a WebAssembly filter. So it then loads it dynamically, so not statically precompiled or inside the container, so you can literally just give it a little bit of configuration, like, hey, this is where you can find your WASM module, and if you import it, you have to use it as a filter at this stage, so you can even specify when it needs to happen. Now, this is all very nice. This is how essentially ProxyWasm fits in the whole puzzle. But if we look at how you are supposed to use it, you get slightly limited options. That's because ProxyWasm, and this is just a screenshot from their GitHub repository where the spec is maintained, it currently only has SDKs for a couple of languages, and it only has a couple of host environments. So in the SDK list, we're like, well, we have to pick one of those, and we're definitely not going to pick C++, and we're not going to go choose Zig, because we don't know anyone who knows Zig, so that's kind of problematic. So yeah, we have to choose one of the others. But what is very nice is that Envoy Proxy and Istio, which is essentially just Envoy, so I don't know why it's listed twice, but they're listed here. They're like, well, this is definitely going to work. So when we discovered that it was possible, we went into the spec, and then we discovered that, well, there's a bunch of language, some of which we know, and it supports our proxy, which is also great. So this might be our solution, to have this custom authentication thing inside our ingress gateway, and then nobody has to rewrite their service. So that's pretty nice. So you click on the ProxyWasm Go SDK link, as you do, and you end up in this repository, which is maintained by Tetrate Labs, which I think is also a sponsor and has been around for a while to do all sorts of cool traffic things. Well, we do know a bit of Go, and we just wanted to know, how easy is this to use? Is this something that we need to, I don't know, take a 12-hour course for or something? So we go to the repository, we find this nice examples directory, and what do you do with examples? You try them out. So one of the examples, and if you're not a software developer, don't worry, I'll just very quickly explain what's happening here. The examples, in this case, a request header example. What they have is a bit of code, and this is slightly modified so it fits in the slide. But what essentially happens is you define a function, in this case on HTTP request headers, which means that you essentially tell ProxyWasm, like, hey, if you reach my filter and you have headers, this is the function that you're supposed to call. And well, that's what it will do when you load the filter. And what we then do is we say, hey, ProxyWasm, give me all the request headers that you have. So you get a list of all the headers, the key value pairs essentially, but not much else. So it doesn't do any nice fancy decoding for you. Then below that, there's a little bit of a error check just to make sure that you actually did get any headers. And below that, there's a for loop where we essentially say, this list of headers, this is nice. I want to have all the headers in this list, and we'll print them out into the log. So it doesn't actually do anything with the headers. It just shows you that the filter was loaded and that it knows how to read the headers. And then at the bottom, we say actually continue, which essentially says, hey, ProxyWasm, I'm done. You can continue with your normal proxy business. So we tried this out, compiled it. You know, the instructions was in the README. README says copy this, paste that, run this, and well, suddenly if it was a module, you load it into a standalone Envoy container, just on your local machine, nothing fancy, and indeed it works. You get your request headers logged into your log file. So what this tells you is that as from an engineering perspective, that your engineering loop is complete. You have your code, you have your compiler, you can load it, you can test it, and you can send traffic through it. So that's pretty neat. So it gave us a lot of confidence, like, well, this is easy, this is going to work for everything. We're immediately going to build like the bestest authentication layer ever. Well, of course, that's not how it works, because what happens is that you have your token, your JSON Web Token, which is, of course, encoded, like the name suggests, in JSON. What happens when you try to decode and encode JSON in the Proxy Go SDK? It doesn't work, because the SDK requires that you use TinyGo, not the full version of Go. And TinyGo, which was originally developed for microcontrollers, doesn't support a whole bunch of things, including lots of reflection. Reflection doesn't necessarily matter if you don't know what it is, but what does matter is that it's not supported, but it is required if you want to do any JSON stuff with the standard Go JSON library. So could we avoid this? We could have avoided this because it's in the documentation, but we didn't read the documentation. So that was, well, our fault. But we figured, well, what if we just don't use reflection? And what if we just don't use any of the standard built-in libraries? So how hard could it possibly be? Well, it's very hard, because you have all sorts of text. This is a screenshot from the jwt.io website. It's a very useful website if you want to know a little bit about the tokens. It starts out as some base64 encoded string. You decode that into JSON text, and then the JSON text gets marshaled into a struct. So that's how you, from the outside in, you take what's in the HTTP protocol, and through a few steps, you get an object that you can actually use in your code, which is important. Otherwise, what you're going to do, you don't have any way to interact with your token. So there's quite some variability in here. You can have your tokens be, for example, malformed, or you can have them very large or very small. You can have very different types of tokens. So when we try to make a parser, because, well, what do? Reinvent the wheel, because that's always a smart idea. But it just doesn't work very well. It's not very performant, and it usually just breaks. And we're like, well, this is not something that we can ever take into production. So what do? Well, we look around and we try to find if someone else has had this problem, because we're not some unique company in the world. I mean, there are many companies and many people who use JSON. So we looked around and we figured out that there are many reasons why other people use JSON libraries that are not based on reflection, primarily for speed. So it apparently is like 100 megabytes per second difference if you use a JSON library that doesn't use reflection. That means for us that we can use such a library that doesn't use reflection in our TinyGo runtime. So that's pretty nice. So that solves our JSON problem. Now, we didn't end up with specifically TinyJSON. We used the JSON iterator, because there's always a trade-off. So the native Go JSON library but we try to import in ProxyWasm, it has a very nice way, a very ergonomic, developer-friendly way of parsing and using JSON. These other libraries, they don't. They usually require you to do something very specific, like manually describing in your code how you go from a text-based input to a struct or object that you can actually use yourself. And some of them try to help you a little bit by pre-generating some code. But when you move from the standard library to a different library, well, it's a trade-off in size, in speed, in ergonomics. But it's fine. I mean, it's just a bunch of JSON tokens. As long as it works, we're happy. So on we go into the actual logic that we have to implement. So you get yourself a cookie, comes in, got this big, very long base64 encoded string. We take the string and we decode it into text. We take the text and we decode it into a JSON Web Token object that we can use in our code. And on the side, there's a little bit of text on the left side that contains the header of the token, and it contains a key ID. And then from our environment variables, we inject a JSON Web Key set, and that contains also base64 and JSON encoded a list of keys that we know. So that allows us to match the key ID of the incoming token to the key ID of the keys that we know. Do we have a match? We continue. If we don't have a match, we say, well, we can't validate the token, so it's going to be invalid by default. But if we have a key, that's nice. We can verify the signature, and if it's valid, we can do all sorts of other logic, like, has the timer expired? Is this a token that's 5 years old? Well, then maybe we don't accept it. But this one is the important bit. Why is it the important bit? Because we tried it, and it turns out that you can't just read cookies in tiny Go, because reading cookies in Go requires that you use the net/HTTP package. That package requires that you have crypto/TLS, and that package doesn't work in TinyGo because it doesn't work in ProxyWasm. So that means that we can't use that package. And parsing cookies is not something most people would enjoy. It's almost at the same level as trying to work with dates and times in code. It's not a lot of fun. So we did hack around a little bit. So we just went to the source code of the net/HTTP package, and we were like, well, read cookies. Doesn't sound like it should be using TLS. Maybe the code is standalone and we can just steal it. And that's what we did. We just steal the read cookies code. Works like a charm. Excellent. Problem solved. Except, no, not problem solved. Because the next step, and we should have known this, because if TLS isn't supported, then AES and RSA are probably also not supported. And we should have, of course, read the documentation. But yeah, we use RSA. What's not supported? RSA. So yeah, that's a problem. No RSA, no tokens. So it means that no matter how hard we're going to hammer on this, and we're not going to implement our own RSA encryptor and decryptor, that will be the worst of all worlds. So now what? Well, turns out we can't use Go. So that's a bit of a bummer, because that's the language we had the most knowledge and the most affinity with. So we essentially just had to go back to the SDK page, pick something else. So Zig and C++, they were out. Go, also out. Assembly script, it looked very weird and very not ready for prime time yet. We also tried it out a little bit, and it just broke at every turn, so also not an option. So you end up with the crab, also known as the Rust programming language. Now, the Rust programming language is slightly different than what we're used to. However, it also has a very big community, and it's very active, very well maintained, and also for some reason very opinionated. But yeah, that wasn't a problem for us, because we figured, well, we really do want this solution, because this seems like the best solution for us. I mean, if we manage to fix this, nobody has to rewrite the service, we can migrate, everybody happy. And it worked. And we don't have like a billion slides with a billion lines of code to show you that it worked, because then we would be here for another hour. But as long as you make sure that you do not import SSL, it works. It just works natively. You don't need to do any special things. You don't need to jump through hoops. You just import the packages and crates that you need. You compile it. Everything works. Except, for some reason, pretty much every package tries to sneak OpenSSL into the dependencies, which is not very great because it doesn't work. And why doesn't it work? Well, probably for the same reason that the AES implementation of Go doesn't work. Because for cryptographic operations, they usually have assembly-based optimizations. So you can make use of all the fancy instructions that processors have. Those instructions, they do not exist in the WebAssembly virtual machine. I think someone is working on it in the web crypto standard, but right now, it doesn't exist. So yeah, the only way to work around that is to disable OpenSSL wherever you can. Go to crates.io to find out if any of the packages you have is trying to sneak in OpenSSL and just not use them. And for some libraries, and this is something that we learned and we really liked about Rust, you can select what dependencies you will enable. So you can have features in your crates that you enable or disable, and based on that, it will just not import dependencies. So it's pretty neat. So yeah, that worked out great. So what did we learn at the end? ProxyWasm, like the slide says, and like the title says, it's great because it's very performant. I mean, this thing is like at native speed. It's not, normally when you have a scripting language or a plugin language, everything slows down. This, native speed. We can do it faster than in Lua, which is always great because that's where we're coming from. But yeah, it's amazing, but support is somewhat limited. So sometimes you have to jump languages from Go to Rust, maybe assembly script one day. And it appears that the higher level your language is, the more problematic it gets. But the lower level your language is, the less problems you have, because apparently they have the ability to compile their code in such a way that if it notices that some instructions are not available, it'll just not use them. Go will not notice this, because Go will just say, I'm going to use assembly, whether you like it or not. And that doesn't work. So yeah, and also there's a tiny bug at the end. When you load a WASM module in Istio, you cannot unload it. So if you want to replace it or you want to remove it, you actually have to change your configuration and then restart your proxy. I think they're working on that, not entirely sure. And of course, if you don't read the documentation, you're going to have a bad time. That was my talk. Thank you. If there are any questions or feedback, I would love to hear something.
Any questions? I have one, actually. So at the beginning of your talk, you mentioned that you moved from Mesos to Kubernetes.
Yeah.
I'm curious to know how many clusters you had in Mesosphere versus how many you ended up in Kubernetes.
Right, so that's an interesting one. We had, I think, about 12 Mesos clusters, and we moved to 50 Kubernetes clusters.
Wow.
And we did that because the team that we did this with was only 3 people, including me. So we, at the beginning of everything, we said, well, the only way we are ever going to do this is with 100% automation. So that means that we use Terraform a lot and a lot of other technologies, and that means that we, at the start of the creation of a cluster, so we have a system namespace, which you call Atlas, that's the platform. And then within that, you can have smaller namespaces for each different brand, for back office, front office, whatever. And within those namespaces, you have environments. So that means if you need to create an additional environment in an existing namespace, it's just you add one additional line in Terraform, and it will create your AWS account. It will allocate you a network. You will get an EKS cluster on AWS. It will create an Argo CD entry for you. You can create a GitHub repository for you where your manifests are stored, and it will create a secondary GitHub repository for you where your workload manifests are stored. So they are separated. And by doing it that way, you can very easily spin up clusters. It was very important to us.
Yeah, and all 50 Kubernetes clusters
Yep.
are pets. Pets.
Yep. So you can destroy them and nothing happens. So they're stateless. One Kubernetes cluster equals one AWS account. And nobody is allowed to add anything except that Kubernetes cluster in that AWS account. So our
so
data...
they're cattle, they're replaceable.
Yeah.
Okay.
Oh, so they're not pets. Yeah, no, sorry, I get it. Yeah, no, they are. They're cattle. And what happens is we actually made it even more cattle-ish. We have a controlling environment, which is also stateless, and that one controls where your deployments happen. And then that can go to any number of clusters. So our workload clusters, they, for example, we have prod, but we don't have one prod. You can have 10 prods if you want. And your service can deploy to one of the 10 prods or to all of them. It's up to the developer. If the developer says, well, my service is very important, needs to be highly available, what do? You deploy all of them. And if one cluster goes away, well, that's fine. Yeah. So we also don't, well, we are testing the EKS in-place upgrades because AWS says that it works, and yes, it does work. But I think for us, it's more important to never upgrade, to just replace, because it means that you also verify your disaster recovery.
Yeah.
And we need to make sure that it's proven. So anytime someone in the company says, oh, we'll just do an in-place upgrade, they're like, no, we're not going to do that. We're going to destroy everything, because that's how you prove that it works.
Yeah. You might be interested in Anne's lightning talk later today about just-in-time clusters, but you won't take any more of your time. Any other questions?
I do have a question. Was it information density okay? Was the speed okay? Was it too fast, too slow? Too many slides, too little? All right. All right. You never know. Sometimes people say that I talk too much or try to deliver too much information, which is probably true. But all right, good to hear. Thank you.
Thanks so much. All right, our next speaker is Unnati Mishra. She'll be talking about deploying with confidence involving best practices with Argo CD. Thanks, Unnati.
Yeah. Hello, everyone. Good afternoon. Myself, Unnati Mishra. I'm here from India. I'll be talking about Argo CD and the best practices that you can use to involve Argo CD inside your cluster. I know we are here after lunch. You all might be feeling sleepy, but believe me, this session will be an interactive session, and stay tuned. So a bit about myself. My name is Unnati Mishra, and I'm here from India. I work as a member of technical staff 2 at VMware, and I graduated last year. And apart from work, I love to play with dogs, and I love dancing. I started contributing in open source since 2019. So this will be the agenda for today's session. First of all, I'll be introducing Argo CD. We'll see the CI/CD workflow with and without Argo CD. We'll see the integration of GitOps with Argo CD. We'll see the benefits and the best practices for GitOps deployment with Argo CD. And at last, we'll see the demo part. So a quick question to you all. How many of you have used Argo CD before? Yeah, that's great. So we'll start with the basics. So Argo CD is a continuous delivery tool. It is having a Git-based approach that is used to monitor and compare your cluster. Or you can say it as a Kubernetes controller that can manage your applications or the cluster. We'll see the CI/CD workflow without using Argo CD. So this is the basic application workflow that you are using for deploying any cluster or making any application. So Jenkins is a third-party tool, which is a CI/CD tool, continuous integration and continuous delivery or deployment. So you can set the Jenkins script so that it can test your code by doing the conformance and upgrade testing. It can build the image, or it can push the code to the Docker hub. And then when you update the k8s manifest file, it will apply the kubectl commands, and the cluster is deployed along with your configurations. So this is the basic workflow using Jenkins. But there are some limitations using Jenkins as a tool for this workflow, because you have to send the password, or you have to share the credentials with Jenkins, which is a third party, which can pose security threat to your application. This is one limitation. And second limitation is you don't have any track of whether your application is deployed successfully or not, whether some pods are like down. So you don't have any track of it. So this is the limitation of using Jenkins in this workflow. Now we'll see how GitOps is integrated with Argo CD. Integration of GitOps with Argo CD involves setting up a Git repository as a source of truth and deploying Argo CD inside the cluster. So whenever you update the Git repository, what Argo CD will do, it will fetch the changes from the Git repository, and it will sync the changes to the deployed cluster. So you don't have to manually apply any changes to it. So Argo CD supports k8s YAML file, Helm charts, and customize.io, which is a template that is used for generating the k8s manifest files. So Argo CD makes sure that above two are always in sync. The Git repository is the desired state, and the deployed cluster is the actual state. So Argo CD compares the desired state with the actual state. So in a more clear picture, whenever some developer updates the k8s manifest file, Argo CD detects the changes and makes sure these two are always in sync. So it will pull the changes or sync the changes in the deployed cluster. So we'll see the CI/CD workflow with Argo CD. So the CI part will remain same. CI part will be done using Jenkins part, and CD part will involve Argo CD. So Jenkins will test the code, build the image, and push the code to Docker hub. And whenever you update the k8s manifest file, Argo CD will sync the changes and apply the changes into the deployed cluster. So there is one advantage in using Argo CD. You don't have to share the credentials to the third party. As Argo CD is deployed inside the cluster, you don't need to share the passwords. It will automatically sync it will fetch the passwords inside the deployed cluster. and you have a track of whether your application is up running successfully or not using Argo CD. So some effective methods of making your project repository. So this is a best practice to use to divide the code part into application source code and application configuration, because you don't want your whole application to build again and again whenever you make a small change inside a application configuration or the manifest file. Suppose you want to make the replica or the pods as 4. So you don't want your whole application to be built again and again. So you can divide your code into application source code and application configuration into 2 Git repositories. We'll see some benefits of using Argo CD. First is automation. So you don't need to apply the kubectl commands manually for deploying the changes into the cluster. Argo CD automates the whole process. Continuous deployment. Whenever you make change inside the Git repository, it will sync the changes. So continuous deployment. Version and access control. So as you are using a Git-based approach, it is having the version control, and it makes it easier to everyone to collaborate inside your project. Next is monitoring and validation. So Argo CD monitors the changes from the Git repository, and it validates the change inside the deployed cluster, whether both are in sync or not. Next is disaster recovery. So due to some technical or physical issues, some pods are not running, or like some pods are down. So Argo CD will compare the changes from the desired state to the actual state, and it will bring up the pods which are not working. Scalability. Argo CD can be used for small-scale application and large-scale applications also, as it can manage many clusters simultaneously. Best practices for GitOps deployment with Argo CD. You need to define your infrastructure as a code. That is, you need to define all your code inside a Git repository using a Git-based branching model. So using Git, you can, like a person, like if you're making a project, then it can be easy for everyone to collaborate in your project. So you can deploy your application after testing. Like if someone makes changes directly inside the cluster, then it should be tested and then it should be deployed. So using a Git-based branching model helps here. Encrypt the sensitive data. You should use password management systems like APIs and other tools to encrypt the sensitive data so that no third party can access that. Regularly review and update the GitOps process. You should be up to date with the updates and all the other things that are used for maintaining the updates for GitOps. Now in the demo part, we'll install Argo CD inside the cluster. We'll configure Argo CD with the application CRD, and we'll test the setup by updating the deployment.yaml file. So first of all, you need to have Docker installed in your system. Next, this is the documentation that you can use for the basic information using Argo CD inside your cluster. So this is the getting started guide, in which you have the information how to install Argo CD, what are the prerequisites that you can install before using Argo CD. So first of all, we should have Minikube inside our local system, because it creates a single node cluster to test our application that we are going to create. So I have Minikube running, so I'll start Minikube, and it will create a cluster inside my local machine. So you need to download Argo CD, brew install Argo CD, and then you need to create a namespace Argo CD. So Minikube is installed, and we'll create a Argo CD namespace. by installing the YAML file, it will install all the dependencies that are used by Argo CD to control the operations. We have the Argo CD server, Argo CD Redis database, and all the other components that are used by Argo CD to control the operations. But the Argo CD server is in the form of cluster IP. We'll see. kubectl gets service of the namespace Argo CD. The Argo CD server is in the form of cluster IP, but we want to access the server, so we need to port forward it. So here's the command for port forwarding. kubectl port forward of the namespace Argo CD. As you can see, Argo CD server is deployed inside the Minikube cluster in the 443 port. So we have to change the port so that we can access it from a local machine. (8080) from our local to 443 so that we can access it. So if we go and access this IP, we can access the Argo CD server. But for that, we need to have the admin credentials. So if we go to the IP, we can access the Argo CD server. But we need to have admin credentials, which are stored inside the Argo CD namespace. So we need to fetch that password. So the command for that is Argo CD admin initial password and the namespace Argo CD. kubectl get secret Argo CD initial admin secret. And then the namespace Argo CD. We want the output in the form of YAML file, so we are writing -o YAML. And this is the password that we have received. So this password is in the base64 encoded format, so we have to decode it. Echo the password and then base64 -- decode. So we have to take the password before the %sign. So we'll paste the password and then we'll access the Argo CD UI. So as no application is deployed, we are seeing no application available. So now we'll deploy a simple application. I have this folder in which I have a dev folder, then application.yaml, and inside the dev folder, I have deployment.yaml file and service.yaml file. Three files are there in total, deployment YAML file. We have the API version as version 1. Kind is deployment as it is a deployment.yaml file. In the metadata, we have the name of the application. In spec, we have the name of the app. We have the replicas. And inside containers, we have the name of the image and then the container port. In the service.yaml file, we have the API version as v1. The kind is service, and then the name is my app service. In specs, we have the port and the target port. In the application.yaml file, you have a minimal application spec in this documentation which you can follow for creating any test application. we have the source and the destination here. Source will be the source where the Argo CD will compare the changes that you have applied in the K8s manifest file. Target will be head, and the path is dev, as I have the files inside the dev folder. The destination is the server, which is the default Kubernetes service. Namespace is my app. Now, automated self-heal is true. That means like whenever any pod is down, so it will self-heal itself. It will compare the Git repository with the deployed cluster, and it will bring back the changes. We'll apply the changes. kubectl will apply, and then application.yaml. So we have the application running here. And it has synced the changes from the Git repository. So inside this, you can see the summary, like cluster information, namespace, when it was created, and all the parameters. The image name. This is the manifest file. And all the events, like when was it updated, when was the operation completed, at what time. You have all the information here. This is a desired manifest file, and this is the live manifest file. So live manifest file is the file in which the cluster was deployed. Desired is from the Git repository. So here I have 2 replicas inside my deployment YAML file. Suppose I want 4 replicas or 6 replicas. So I can change the file, and then I'll update the Git repository or the K8s manifest file. So I'll make the replica as 4. I'll push the changes. The changes are pushed, and then we'll see the Git repository. So the dev folder was updated. Now Argo CD will sync the changes in few minutes inside the deployed cluster. See, now the pods have become 4, as I have changed the replica as 4. So you don't need to apply it manually. Argo CD will fetch the changes from the Git repository. Now here I am changing the name of the app as my Argo app. And I am updating the changes in the Git repository or the manifest file. Now everywhere the name will be changed. See, the file is updated. The name is updated here. And inside the server also, Argo CD server, we'll see the name updated. My Argo app. Now suppose if someone updates the cluster directly, so you should have a configuration so that no one can update the cluster directly. You should only, like Argo CD always fetches the changes from the Git repository as a source of truth. So no one should modify the cluster directly from the local machine. So if I do kubectl edit deployment, and I'll change the replica as 4 or something else. I'll change the replica as 8. So as per the Argo CD operations, it should not accept the changes because the source of truth, that is the Git repository, is having different configuration. So it will delete all the extra pods that are created here. So you can also, like if someone wants the changes directly to be applied inside the cluster without Argo CD to compare the changes and then apply it, because Argo CD takes few minutes to apply the changes. So you can set up some configuration for admin access. Like few developers will be having the access to make the changes directly to the cluster. So you can set up something like this. So this was the demo part. Do you have any questions?
That was a great demo. Thanks. It's great. My question is, or two things. I mean, so Jenkins, you don't need Jenkins. And am I right? And the other question is for those teams, they have different people. They might be looking at Flux, for example. What can you say about the potential collaboration there using, for example, Flux and Argo CD? Is that viable?
Both Flux and Argo CD.
Yeah, and not with the same an organization might have the developers preferring Flux, or certain element, or the operations teams, they might prefer certain elements of Flux, and might prefer certain elements of Argo CD as well. So, can there be a marriage there between the two in an organization?
I haven't worked with both. Like, I don't have much idea about it, but I'll come back to you.
The first question, though, so Jenkins, you're essentially with Git repository.
Like, we have a way to track the changes with Jenkins also, but it is a bit complicated process.
Right.
Yeah, so we can use Argo CD instead of that.
Okay, so the developer shouldn't have to worry about Jenkins. Is that what you're saying?
Yeah, no.
To your second question, I think I saw a LinkedIn post from Alexis from VWorks, where he was talking about how Flux can work with Argo CD today. So, yeah. Any other questions? Thanks so much, Unnati.
Thanks, everyone. You can connect with me on LinkedIn and Twitter. Thank you.
right, our penultimate speakers are Selvi Kadirvel and Pavel. Pavel is out sick, unfortunately, so he'll be on the recorded call. They're going to tell us what we are missing in our GitOps pipeline. Thanks, Selvi.
Thank you, Madhuri. Okay, I'll wait for the slides to come up. Okay, great. Good evening, everyone, and thank you so much for choosing to be here. I'm Selvi Kadirvel, and I'm from Illotl. Pavel, as Madhuri mentioned, is going to be watching the live stream. Thank you, Pavel, and he's going to give us an awesome recorded demo. And most importantly, Team Illotl, it's their work that made this talk possible, so... Okay. So I know you've heard a lot of GitOps today, so we're going to start with a little bit of trivia. I love trivia about software projects. So the term originated from Vworks. So they had a push to production back in 2019, which caused the entire production cluster to fail. And in about 40 minutes, they were able to bring up all their components back up. And during the post-mortem analysis, they said, we're doing something right. This worked out really well. All of their manifests were in Git, and they had all of the core principles kind of defined at that point in time. Their CEO, Alex Richardson, called it GitOps. He shared it with a friend who told him it was a really ugly word. And he said, perfect, people will remember it. And so that's what we keep hearing of GitOps. So even though some of you might be familiar, we're still going to do a little bit of an intro, so we're all on the same page, so bear with me. We've chosen our GitOps tool of choice to be Argo CD, so we'll do a little bit of basics. And then we'll talk about why organizations need to be scaling their Kubernetes environments and how this leads to the need for the missing piece we'll describe. We'll do a little demo, and we'll tell you how you can try everything out. So GitOps can be defined as an operating model for deploying your applications to Kubernetes environments. Its core principles include a declarative desired state of system. This simply means that you want to describe your system as a set of facts and not as a set of instructions. You want it to be versioned within a single source of truth, which will be your Git repo. This all seems pretty obvious in Kubernetes environments. We do have declarative manifests, and we are, checking them into our Git repos. But the key core piece is a pull model of deployment. This means that instead of your CI/CD pipeline pushing your manifests into your Kubernetes clusters, you want your GitOps engine or your controller to be pulling manifests from the Git repo. And you want it to be continually reconciled, which means if there's a user error or in your environment, you want this to be automatically reconciled and eventually go to the desired state of the system. So these are the core principles. We've chosen Argo CD, and a core concept or construct within this is the application CRD. This is an Argo construct. It specifies three main aspects. One is, where is my single source of truth? So you'll have, Okay, let me go back. Okay, so your single source of truth is where is my Git repo? You want to be able to specify that. There are a lot more qualifiers to this. I'm just keeping it simple here. And then you want to know where is my deployment environment, which is your Kubernetes cluster's API server. And you have multiple control knobs for reconciliation. Here, for example, is an automated sync policy, which says that as soon as a Git PR is pushed, you want it to be automatically deployed into your environment through a periodic poll, which can be whose time interval can be defined. Now, okay. So in everyone's Kubernetes journey, we start with one single Kubernetes cluster, and soon it's just not sufficient. At the very least, you have a dev cluster, a QA cluster, a staging, and a prod cluster. Soon, your application becomes really important. You want to make sure it's geographically distributed for either performance needs or latency needs or just for the purpose of failure domains. And once your application cannot be developed by a single team, you have different teams building different microservices that need to interoperate together. Once again, there is a need for multiple Kubernetes clusters. And if you're in a large organization, each of business units develop completely independent products, and you have a bunch of Kubernetes clusters come up. I've been in teams where we've had a Kubernetes cluster brought up for every single PR because we were developing Kubernetes tools that needed to be on a greenfield deployment. I've also been in teams where the entire team shared a single cluster, and we were all isolated by namespaces. this. So I'm really curious, what part of the Kubernetes journey you're in. If you have between, say, 0 to 5 clusters, could you raise your hands? Okay, awesome. 0 to 5. 5 to 20 clusters? Okay, a few of you, 3 or 4 people. And 20 to 50 clusters? Anyone? Not yet. 0 to 5, okay, cool. More than 50? Awesome. So yeah, so we're all definitely going to be getting there soon. So, okay. So how do we scale to multiple clusters within Argo CD? Very obviously, you'll have to have a separate application CRD for each workload and each map to each Kubernetes cluster. Seems pretty simple. Seems like that would work for a handful of clusters. But what if you have more than a handful of clusters? Argo CD does make it easy for us to be able to do that through a concept called application set. This is a templating mechanism using which app CRDs are created automatically through what is called as a generator. There are multiple generators. The ones that's relevant to this use case is the list generator and a cluster generator. In a list, like in this example shown here, you typically list your set of clusters, and these the templating mechanism will create the app CRDs for each of the different target clusters. In the case of the cluster generator, internally, Argo stores its clusters as secrets with configuration on how to access that cluster. That can also be used as input to the templating mechanism. So yes, it seems like it'll work for a number of clusters, but the missing piece here is not exactly the missing piece. The kind of limitation here is that the mapping between your workload, sorry, that's not very easy to read. I've written mapping between the workload to your cluster is static, which means that it works for deterministic use cases, but there are a number of use cases where you want to be able to use the cluster's current status to determine where your workloads will be placed. Let's look at some use cases. First, for example, my team has 3 dev clusters, and I have a workload that I want to be placed in any one of them, as long as it has sufficient resources. A second use case, let's say I'm running a training ML workload, and because of some changes in data source, I want to increase the number of replicas in my deployment for 10 to 30. I want to say, hey, if the current workload that's running on won't work well, can you please seamlessly migrate my workload to another? I want to be able to say this to my deployment environment. Secondly, another third use case is, say I'm ready to push my code from staging to prod, and I want to say, place this workload in all of our AWS regions in the US, except the US West region, because it so happens that that's our highly loaded region, and we usually do that a few days after our first push to prod. So in order to address use cases like this and this category, we believe the missing piece is a multi-cluster orchestrator. Let's look at what this is and how it can help. Okay. A multi-cluster orchestrator refers to a group of Kubernetes clusters whose workloads is being managed and orchestrated by a top-level control plane or a management cluster. Now, this is a up-and-coming area of Kubernetes tools. Some of the available solutions are Red Hat's Open Cluster Manager, Elotel's Nova product, KCP, another project from Red Hat. It's transparent multi-cluster. Huawei Technologies has a product called Karmada. So these are multi-cluster orchestrators. You might ask, how is this different from a typical Kubernetes management plane that lets me view and access multiple clusters? The key difference is that a Kubernetes management plane allows for cluster lifecycle management, which means your day 0 to day n operations of provisioning, configuring, and maintaining your clusters over its lifetime. And a cluster orchestrator provides a service at a higher level of abstraction. It says your clusters are available, and there, now how do I place my workloads? That's the question it's helping you answer. Okay, so let's go deeper into a multi-cluster orchestrator. One of the key concepts is a schedule policy. These are called differently. Open Cluster Manager calls it the placement policy. Karmada calls it the propagation policy. In a sense, they're all trying to address the same user need. So it answers 2 important questions. Which resources does this policy govern? And which is the subset of clusters in my environment that I want this policy to consider? And how do you define the resources? So you can choose labels. So all your Kubernetes objects that have, say, the app nginx key value pair need to be addressed by this policy. Or you can say all the resources within, say, some namespace XYZ need to be placed by this policy. Then, which clusters do I need to consider? So you can talk, once again, labels provide a flexible mechanism to do this. So in the first use case that I talked about, you could say env refers to all my dev clusters, choose one of them. Similarly, you also can provide inclusion and exclusion lists. So in my third use case, it would be that I talked about, it would say, hey, place it in all of my US East and other regions except for my West region. So you can provide include-exclude lists. So this is a simplified rendering of the schedule policy CRD. It just talks about which resources, which clusters. And you can use a range of combinations of these to define what your policy is. Okay, so how do we integrate Argo with a multi-cluster orchestrator? This depends on the design choices made by each orchestrator. We'll show you an example with Nova. In this case, there's simply two different things. There's just two different things you need to do. One, within the Argo application CRD, instead of providing the direct Kubernetes cluster where you want your workload to be scheduled, you would provide the control plane of your orchestrator. Its API endpoint will accept workloads and make placement decisions based on the schedule policy. And then in addition to that, you will have a bunch of manifests, which are your schedule policies, which will do the dynamic mapping. We'll look at some examples of that in the demo. Okay, so we're just going to go over the same use cases. I'm going to talk about in yellow the actual feature that enables this use case from an orchestrator. So in this case, what we care about is resource availability. So capacity-based scheduling would be the feature in your orchestrator that would allow this type of placement. In the case of a place where I wanted to intelligently move my workloads, it would be workload migration, the feature of your orchestrator. And finally, in this is the cluster inclusion and exclusion methodology, wherein you would specify, hey, place it in all regions except a couple of regions. Okay. Before we watch the demo, let's give you a quick outline about it so you'll know what you're watching. We will have an Argo deployment and a cluster orchestrator. It'll be running on a combination of Google GKE Cloud as well as on-prem clusters. So we're just taking kind clusters to keep it simple. We'll show you where the integration point between the two is. We'll show you how a schedule policy looks like and how different configurations of the resource and cluster selector work together. There's a couple of concepts that I'll go into before the demo, which is group scheduling. So we've been talking about Kubernetes resources, but typically a group of Kubernetes resources is what makes an application. How do we specify these resources are related, and I want to place them in the same cluster? There's a couple of ways orchestrators do that, either through labels or a separate CRD. In the case of Nova, we use labels, and internally, Nova automatically creates a schedule group that puts together resources. Manifest work is an example through Red Hat's OCA Open Cluster Manager, where a manifest work is a new CRD, which is just a combination of all your other resources to be grouped together and placed together on the same cluster. So even workload migration needs to check if all of those resources will be possible to be hosted in a new cluster. Then there's another concept called spread scheduling. This provides an extra control knob for slightly different use cases. So for example, if you want the same Kubernetes resources, not on any one of your subset of clusters, but on all your subset of clusters, for example, a namespace. Before you send your Nginx apps, you expect certain namespaces. You can use the spread scheduling policy. And similarly, there's another aspect of spread, which is a single Kubernetes resource can be split across clusters. Say if you had a deployment with 100 replicas, but you wanted to split it as a 75%, you could use this policy to place your workloads. Okay. Hey, Shepard, can we start the video now?
Hello, Rejekts. It's Paweł Bojanowski from Inotl here. I'm going to demo how can you leverage multi-cluster orchestrator with Argo CD. So in this short demo, I will show how platform team can upgrade cluster versions in a way that is invisible to application developers and reliable at the same time, because we'll test if everything works on the newer Kubernetes clusters first. So let's talk about the setup we have here. So our assumption in this demo is that we have two personas, the platform engineer and application developer. So application developer has the guestbook application, and the application itself only points to the Nova control plane, right? And it's platform team responsibility to ensure that the application runs, and for high availability, platform team wants to spread this application onto two clusters. So as you could see, we only have Nova cluster connected to the Argo CD, but the platform team has access to the Nova control plane. And in the Nova control plane, we have 4 workloads clusters connected. So we have some clusters in the cloud, some clusters locally, and we have 2 clusters with 1.21 and 2 clusters that we just connected with 1.25. They don't run anything yet, but we want to test our guestbook app, which currently runs on those 2 clusters. So we want to test it in one of these clusters first. And hello Rejekts, it's Paweł Bojanowski from Inotl here. I'm going to demo how can you application itself only points to the Nova control plane, right? And it's platform team responsibility to ensure that the application runs, and for high availability, platform team wants to spread this application onto 2 clusters. So as you could see, we only have Nova cluster connected to the Argo CD, but the platform team has access to the Nova control plane. And in the Nova control plane, we have 4 workloads clusters connected. So we have some clusters in the cloud, some clusters locally, and we have 2 clusters with 1.21 and 2 clusters that we just connected with 1.25. They don't run anything yet, but we want to test our guestbook app, which currently runs on those 2 clusters. So we want to test it in one of these clusters first, and if it works, we'll be moving gradually to the new clusters while sunsetting the old clusters. So that's the demo scenario right here. Yeah, so as I mentioned, the guestbook application is currently spread across to v1.21 clusters. So how platform team did that? Well, they defined schedule policy in the Nova control plane, and in that policy they said, in the namespace guestbook, please select all the Kubernetes resources which has this label set, group them by version. So I currently have only guestbook version 1, so all the resources will be in the 1 group, and schedule them to the clusters which match this expression. So to the clusters which has version 1.21, and to the clusters that the platform team didn't label as clusters under maintenance. So if we get back to the console here, and if we describe our clusters, you could see that each cluster object has a set of labels, like version, and it could be any custom labels that you can use in the cluster selector here. Yeah, there's one more thing. So the platform team decided to spread this group across 2 clusters. So they said, please spread it across those 2 clusters and use the name as a topology key, meaning that 50% of the replicas will run in one cluster, and 50% will run in the second cluster. So right now the platform team wants to create a copy of the same application, and they want to run it in one of the newly connected clusters with higher Kubernetes version, just to ensure that all APIs are working and basically that there were no breaking changes in the Kubernetes itself. So the platform team prepared this new schedule policy, and in the new schedule policy they said from the new namespace, which is named guestbook test, select all the resources, and this time schedule them only to one cluster, and that cluster has to be version 1.25. So I will go ahead and sync that policy that platform team prepared, and they also prepared the guestbook app copy basically. So the copy itself has the labels, so it will be matched with the schedule policy that we just synced. If we now sync the guestbook test app, we should see in the events for that app that the test guestbook schedule policy was matched and that the objects were grouped, and they should land in one of the newly connected clusters. So if you go here and check the live manifest, there should be cluster annotation added saying that it will be running in one of the new clusters. So let's just wait a bit until it's all synced. Okay, it says that it runs in one of the target clusters. I can verify it also in the console. So
hey, Shubert, thank you. That's would be good. We can stop the video. Okay, so yeah, we just wanted to show that the schedule policies were changed, the workloads were targeted to the right cluster, and you'll see evidence of that.
Nova context, I can do like get
hey, Shubert, we can stop the video now.
Guestbook.
And go back to the slides. Thank you. Okay, awesome. So, so we did see that the workloads were placed on a different cluster depending on the schedule policy constraints, and we could verify that new labels were added to the cluster and ensure that it worked. Okay. So one thing that I wanted to add was our multi-cluster orchestrator is just a missing piece. No, they're not. They can be used independently if you have a group of clusters to manage your workloads. In addition, in addition to policy-based scheduling, migration of your workloads and spread scheduling, we also have certain specific features where a workload can trigger provisioning of a new cluster. We refer to this as a just-in-time cluster. If that's something that's interesting to you, please attend Holler's lightning talk at end of the day today. Okay, so in summary, GitOps strategies are quite powerful for deploying Kubernetes applications. You can augment its power through multi-cluster orchestrators, and the key benefit is the ability to dynamically map your workload to your clusters. You're also able to track your current cluster's resource availability and make more intelligent placement decisions. In addition, this allows you to migrate workloads across your fleet of clusters. Okay. Happy to take any questions, and if you're interested in trying it out, yeah, these are your links.
Have you tried attaching more than 4 clusters to Argo? Because there's been a conversation on the Argo Slack that it probably doesn't scale itself beyond maybe sort of 10, 20 clusters.
Okay.
I had a customer that wanted to run 15,000. There's some alternatives where that CodeFresh have where it's agent-based. Mm-hmm. But What have you seen? There's a gentleman just across from me that said he had 50 as well.
Okay, so the advantage is that to Argo CD, we're connecting just one cluster, the multi-cluster orchestrator's API server. This orchestrator is aware of the workload cluster. Its duty is to manage your fleet for you, while Argo is only talking to a single point here. So there's no scaling of Argo involved here. It's the orchestrator that does your fleet management.
Is a single point of failure instead, and the bottleneck.
High availability is something that we're designing for, because it in itself is a Kubernetes applications. A lot of the principles that the Kubernetes environment gives us, we leverage.
One thing I was just wondering about is what are your developers putting in the Helm charts that they're providing? Because if you put a deployment there, Nginx, and that was in your chart, and then it was applied to this Nova, is Nova going to try and run that? Was Nova a fake API server that proxies that on?
Could you say that again? So what happens to your Helm resources?
So let's say you have a Helm chart.
Okay.
You checked it into Argo, and it's going to just run Nginx as a pod.
Okay.
When you put that in a normal cluster, it will actually start the pod. You have this Nova control plane. Is that an actual Kubernetes API, or is it a fake API that receives it and then proxies it on to another?
It is a real API server, but it does not schedule it on itself. It finds the right workload cluster and just passes on the API, passes on its workloads to that.
So you can use the native Kubernetes objects, because the early work for this, the federated deployment object.
Yes, kubefed, and yes, this is very similar. Yeah.
But with the native objects.
Yes.
Yeah.
Yeah. You don't need to have any. Yes, it's 100% Kubernetes API conformance.
Is this your commercial product, or is this what's the license for it?
We have a free trial mode where you can manage a limited number of clusters. But if you wanted to do large clusters, it would be the enterprise version.
Cool. All right. Thanks.
Up to 5 clusters are free. Yeah.
Thank you.
Any other questions?
For the cluster orchestrator, there's been a lot of discussion about cost savings, optimization, and I guess my question is, the developer, they're not going to be concerned with this, I would say, or not. But at the same time, for the operations people, how could this be used to save costs, like cloud cost, or maybe it's not relevant?
Right. Cloud cost could be a factor, right? All that the developer wants is, find me a place where it works. It's the platform team can define a policy that says, hey, give preference to our, on-prem clusters. And if that doesn't work out, then choose your, our cloud clusters. So it could, yes.
Is it possible to automate that, though, that process?
It would have to be defined by someone, because it's a kind of what is higher priority to you. It would have to be modeled in the policy.
Yeah, and if you attend Ant's just-in-time cluster talk later today, you needn't even have an always-on control plane. So that's also cost savings and additional cost savings as well. Yeah. So you don't have to have always-on fleet of clusters. Okay. Any other questions?
So you mentioned that you push the workloads to Nova, and then Nova decides which cluster to schedule it to. So how is Nova then scheduling the workloads on that cluster? Is it using Argo as a mechanism for how it pushes to that cluster?
It is a push mechanism. It's not a pull mechanism. The workload clusters don't. The agents do pull from this one, but it's not. It's not GitOps. You're not using any GitOps tools. But the agents are pulling from the Nova control plane.
Gotcha. Okay.
Good question. Thank you.
A little bit of inception. Huh? Any other questions? Thanks so much, Sylvie and Pavel.
Okay. Thank you very much.
Thank you all for sticking around. Okay. thanks all for your patience while we worked on the connectivity issues. It's going to be the last talk of the day in this room. Max will be talking about why developer platforms and a dedicated platform engineering team is a must-have. Thanks, Max.
Thank you very much. Yeah, my name is Max Körbecher. I'm founder of Liquid Reply. We do all the cool stuff around cloud native and Kubernetes. Means we try to make someone's life a little bit more easier. But in the night, I'm working most of the time on some kind of open source projects, whatever it is, or organizing KCDs like in Munich or Ukraine, and do some other stuff. So quite busy in the space around Kubernetes and cloud native. First thing first, who of you would see himself as a platform engineer? At least a good amount. And who of you has a platform engineering team in his company? Some more. It's nearly the same amount. Well, this is quite interesting, and it's a quite interesting trend because we see that over the last year, it's almost have tripled to sometimes like multiplied by 5 to 6 times, depending on some countries, the amount of platform engineering teams where they are grown. All right. And I think here the platform engineer got lost a little bit. Just to let you know, our screen is a little bit 90s out of signal style. Well, maybe, perfect, nice. So this is not a problem, or this is not an issue, and I do not want to show you now my holiday vacation pictures, because I just take this last Saturday here on the beach in Amsterdam. And why I show you this is actually quite a nice little anecdote, which I found out was like maybe fitting to the situation. So my wife, me, were running around there. It was a little bit windy. The sand feels more like it's brushing away everything else what I have on my face. And so we find a nice little bar, sit down, or we wanted to sit down. When we entered, the waitress asked us to stay, while the sign, which was on the entrance, told us to just take whatever seat we want to take. The next waitress, which immediately, like 5 seconds later, come to us, was like, guys, you can just take any seat which you want. So we go, we sit, found the table. As usual here, you have like often these QR codes on the table. So you scan it, you can start your order. What do you want to drink? What do you want to eat? So me as a nerd, I'm like, hey, cool, awesome, I would like to have this one. Oh, salmon sandwich. Oh, it's gone. Sad, I need to go for something else. And then the waitress come and asked me, like, hey, what do you would like to order? I was like, okay, wait, I confused. Well, I have started my order, but you're asking me, so I start reading what I have already typed in and so on and so forth. Nevertheless, in the end, we actually got what we want. Why this is so relevant? Well, for me, this is actually representing a little bit something of platform engineering and what we see as a DevOps. The waiter is just also continuously solving problems which coming in. Whether it's someone who needs to find a seat, take an order, I don't know, maybe someone dropped down his glass and break it, so we need to tidy it up. While on the other hand side, someone beforehand made a thought like, okay, you can sit everywhere where you want, you can order through the app, you can pay through the app, and the only thing which needs to be processed and triggered in the backend is like to deliver me the drinks, to deliver me the food. It's not the perfect example, but it's a good introduction, and it pops me up like, hey, this is something where I can at least think about like what is maybe a little bit the difference of these topics. So is DevOps dead? Well, also I pretty much like this image. I would say no. It's an evolution. We see all kind of roles out there. We see that we were once in a time all like sysadmins running around, plugging in our USB stick, upload all the kind of stuff. We need hours, days to bring a system. Then at some point in time, we come up with cross-functional teams, which then got to DevOps, and then we had some SRE and so on and so forth. The interesting thing is that all of these roles came and they will stay. They will not just go away. And there's actually not the question like, are you DevOps, are you a platform engineer? No, this has two different focus. The only thing which happens in this space, and that's why I give today a talk about platform engineering, is from a platform engineering perspective, we need to protect a little bit this terminology and do not start throwing in everything what we can find. So when we look at large enterprises, which are also for us like the main customers, they have a totally different modus operandi than any other company which you found there, which is digital native. When you run and your only business is IT, you see the world fully different than when you're a large engineering company, when you're a large chemistry company, manufacturer, and so on and so forth. For sure, you do your digital transformation, but you see IT, and it doesn't matter what you're going to do, you see IT always in a very specific, different light than a Spotify, than a Netflix, or whoever else. And what is this a specific light? Well, large companies are oriented in projects. I gave you money, I gave you time, and you deliver me something. This is the whole business. If you find teams who are implemented in these large enterprises, then they often are just solving some kind of support function. They're not anymore in this driven, hey, I need to continuously move on something, I need to develop something, whatsoever. So the reality which we see is that DevOps, for example, is in the most companies written with a very small dev and a very big ops, asking us, hey, do you can make 24/7 operations for us on the weekend, on the business, out of business hours? And it's like, no, this is actually not where we want to focus. I want to build something cool. I want to make a new feature. I'm planning a new feature release, and so on and so forth. So this is a very, very brilliant chart by Daniel Bryant or the Humanitech people who have actually put this into their platform engineering report. And what you can see in the horizontal lines are like different little domains about like the development tools you get in touch typically. What is your deployment and delivery responsibility, and all kinds of different things. And you see a little bit the cycles over the year. So most of us were around 2010, 2015, very happy if we had our first CI/CD pipelines running. Nevertheless, they were super ugly and had hundreds of shell scripts, but somehow they did what they should do. But what is the most important thing in this chart is this magenta kind of area, which is a cognitive load which is pushed to, which is pressurizing actually the developer. You're not just can focus on just purely develop clean code, bring the next functionality. You have to take care about like some guys like us come around the corner, hey, how much resources does your application now needs? Where do you want to deploy it? What is the network configuration? You need to know and you want to know a lot of bunch of things around it. And the tools are getting actually more and more. Now, it's not necessarily the problem of having more tools, but it's about the responsibility which comes with the tools and which is pushed towards the role of a developer. And we're not yet touching fields like I need somewhere a service catalog, I need somewhere documentation and things like that, which by itself requires often their own team to also keep maintaining this. So what does a platform engineering actually do? Well, there's a very, very old statement, barely to read, but it's from 2017 from ThoughtWorks, which described already the first ideas of this platform engineering. And they say like these teams operate an internal platform which enables the delivery teams to self-service deploy and operate systems which reduce lead time and stack complexity. This idea is very old. It's nothing new. And maybe you could also put already this phrase into like the role definition of a DevOps, for example. But the very, very interesting part is self-service deploy and operate systems with reduced lead time. So it's not about to operate the whole stack with the application, but purely the underlying layer, which is then called a platform. Sometimes this terminology is a little bit disturbing. It feels like, okay, everything is a platform. I'm going to a cloud platform. I want to have a platform as a service. There's everywhere a platform. So it's difficult to talk about what it actually means. But when we try to break it more down to the key aspects, we think about the different approaches which are out there. It boils down for three, I would say more or less kind of major components. There's for sure like 20 other things, but to list them all up, it would get kind of boring, and I will later tell you also that there's a white paper which you can read about platform engineering, which is even better because then you have all the details. Nevertheless, the key aspects are about designing and building a tool chain. And a tool chain also includes to establish workflows, to have the missing and to glue the different parts together. For us, there's, for example, always very relevant, we measure the majority of a workflow and the majority of this tool chain on how less shell scripts do we need. The less shell scripts, the better it is. The more shell scripts you have, the worse. And obviously enable the self-service capabilities, which is sometimes very hard because you often need in your systems very immersive admin rights to grant them access to a cloud platform and start deploying everything. And especially when you want to give the right tooling to a team to maintain their own application, but you do not want to give so much of the access that they can most likely break something. So it's a very fine, balanced area where we need to walk around. And why we all want to do this is to provide an integrated product that covers all operational needs and serves for the entire life cycle of an application. You actually, by the way, can read this also in just like one single line by line, because then it still makes sense what's written there in it. And this all needs to play together with our cloud native world. So it's not like we use the technology from like 10 years ago, but we need to do way more than that. So we need to think about our design for automation, which maybe comes together with also the whole workflow and toolchain part of building a platform. We need to build for scalability and reliability. We need to handle the state. I like this phrase, we need to handle state with smartness and care. I often have a discussion when we build platforms like, oh, we make everything stateless. And it's like, cool. But somewhere you will always have data. Where does it live? In the air? Do you download it and you zip it and then whatever do with it? Is it living in your email system? Where is the data living? So building platforms, you still need to take care about the data. But you need to be smart about it. And that can be sometimes a challenge. And obviously, everything must be, in the one or other way, self-contained. Now, this is actually the picture, and you most likely have seen it because it goes in our little cloud native world that nearly got viral, I would say. Is from the Tech for App Delivery, which has written a nice white paper on platform engineering, or what is a platform. And they come with a bunch of definitions, giving some, I would not say tool recommendations, but a selection of it. Like, this is a good starting point. They give you a good overview at all. And what I very much like on this picture is actually the foundation, where it's written capability and service providers. Because we're not discussing about the cloud provider, for example, itself. Many mature enterprises have so huge internal private cloud systems, they can give you all of these things which you want to have. Database, no problem here. Block storage, fine. Software-defined network, which is separated from the rest of the net, absolutely no problem. Companies can do this. And this is very specific to think about, okay, capabilities I can get everywhere, but I want to abstract it away. And this is then the task for the platform itself. In the other way, I also like to make a joke about it to say, like, this is the actually reduced picture of the CNCF landscape of all the tools out there, and just like get rid of 400 other projects. So when we take a look back on the roles, now we maybe can understand when someone is talking about DevOps that this is a certain team, a team of specialists helping you in a specific area. Not everything, but a very specific area. Sometimes in enterprises, 24/7 support, whatsoever. SREs have an application or product focus to increase the reliability of it. And then comes in the platform engineers. The platform engineers take here a very interesting role because, and that's why we can think back to the beginning, is DevOps dead? No. It just all plays well together. You can have a DevOps team which use the platform teams introduced tool chain and platform, and you can still run SREs. Who is better or your best friend who knows about automation and how to increase reliability than the people and the folks who are working on the applications and who are in some way then also your end customer for it? So DevOps is definitely not that. But platform engineers is a nice support for the whole organization to help them to get rid of all this complexity. In short, we try to offload all the developers from the grown complexity in the past years, from all these hundreds of tools and responsibilities and whatsoever they need to take, and reduce it to a very limited amount. This picture is maybe not 100% fitting to the sentence itself, but I think this is very much representing how in the most companies you see actually an IT landscape. It's a very messy thing. Everywhere is throwing with some phrases around. Here's some containers. There's data lake, whatsoever. Actually, we would need to attend it. We have now data meshes, which is spinning around the whole world, and so on and so forth. And as a platform engineering team, we try to make this as simple as possible so that we do not need to get with this whole complexity somehow. So some of the benefits of platform teams. I would like to maybe hear some of you. What would be your things you immediately pop up with, like, hey, this is one benefit would my team bring? Anyone has an idea? Please. Reusability, sure.
To invest again the same amount of time by different teams solving the same problem.
Mm-hmm. Yeah. You're speeding up things, right? More teams come, no problem. Here's your cluster. We're good to go. Yeah. Any other?
Security built in?
Yeah. Absolutely. Who likes to do security on Kubernetes? It's fun. It's the best thing ever. You just throw stuff on top of it, and on the other side, like logs popping up, metrics, everything is escalating, where you're like, it's secure now. What do you want? Right. So there's a bunch of nice benefits out there. And it's very hard to read. I'm sorry for that. But on the left-hand side, there's written improved application lifecycle. This is something where we see a very, very broad field. Sometimes it's just get a little bit better, not that much. We have one use case where we reduce the life cycle of the application deployment from 90 days to less than 5 days. Just because we screwed a little bit on the CI/CD pipeline, we dropped off some operators which were not needed anymore, improved a little bit also the scalability about the platform, and all the magic was done. And we needed less than 2 months for it. So even from a business perspective, the so-called return on investment is like legit on it. There's also a very other interesting point in it. I've recently discussed with the guys from Gitbot about it, which did a research on how much time does developers spend debugging actually their development experience, either on the local machine or somewhere else. And the quite interesting fact is that most developers spend at least 1 hour per week just fixing their development environments. Up to 30% need more than 4 to 6 hours. And there's even a few percentage which need sometimes 10 hours per week for fixing their environments. And then we are not talking about the deployment and the speed and so on and so forth. So we looked at one of our clients who have a fully integrated development environment running in the cloud system. Everything is chained up. Everything is running automatically. There's practically nowhere, anywhere, a reason that something fails, except somewhere a network is down. And then it's totally out of our hand. This is maybe also the right button thing. The only time where we experienced that we could not deliver anymore any fluent delivery process and experience to one of our customers, which are developers, is when, from in this case, Azure, there was a regional network problem, and we could not reach our services. And last but not least, at least for us, which is also a relevant point, we're looking onto cost optimization. So not only building security by default into it, but we also immediately think about how do we can give the platform the capability to reduce in the night times, on the weekends, for example, its scale. For developer platforms, this is actually quite easy because most of the time, the development team is not going to work in the middle of the night, except something really, really horrible happened, and then I can spin it up. But typically, I don't need this stuff. I can just scale it down. And we carry it immediately, or in the beginning from every project, we bring it from the beginning to reduce the scale of the platform where possible. So our lessons learned from enabling platform engineering. The first one is don't build everything by yourself. This is actually quite funny because we work so often together with, again, large enterprises, and they face very early maybe a problem, start building their own solution for it. And at the point where the platform goes in production, where the platform goes live, there's already an open source tool on the market which can solve also this problem. But somehow there's this need always to show like, hey, I can do this. I'm able to solve this problem by myself. I don't wait until someone else have solved this too. It's fine, but then if this comes, be ready to just exchange it. We recently migrated from one Kubernetes platform to another Kubernetes platform and found out that there's like 3 or 4 self-written controllers we're running. We could all replace them. We add some Kida to it. We had another scheduling mechanism to it, and problems were solved. Because this behavior also can drive to, I do not look around anymore. I don't keep myself informed what else is going on the market when I just focus again on my little tiny world where I need to solve the problems. I talked about this project stuff already earlier, but platform teams are not a project. It's a team. It's a continuously being there facility in a company and have maybe one, maybe multiple targets, but they're an institution. They're not going to change. They should not have any budget cuts in the end of the year. They should not have any hard timelines for deliver something. For sure, timelines are sometimes good, especially when something needs very, very long, but you should never treat a team, a platform team especially, as a project. Because what we see is that typically after 1 year, 2 years, a whole team just get a budget cut, everyone gets distributed somewhere in the company, and then they try to find somewhere else who can keep this thing alive. This doesn't make sense, especially because we are talking all about that we need to run several hundreds of updates per year. And then we need to replace tools because they're getting better, they're getting improved, they're getting new approaches into it. The third lessons learned, which is always very difficult to formulate in some way, but I try to, is this that we need a commitment from the team towards the whole vision and mission of like what is expected to be built. So that on the return on this, you can give the freedom and trust like, okay, you're going to catch whatever is going on. What does it mean is, and this should be not like disrespectful, but what we see sometimes is like that people are staffed into teams which absolutely do not want to work there. And when you miss this commitment, for sure they maybe will not drive it. They maybe will implement what you ask them, but they will not drive it. And this is a very, very big difference. If you find drivers in your team, you can give them all the freedom. Here's your budget for trainings. Here's your budget for playing around with other tools. Here's your budget to go to Amsterdam, enjoy a little bit the time, and do all the good things and exchange, get new ideas. In recent times, we see that also here, we see a lot of cut downs of budgets in this way. And last but not least, things are changing, especially in our world. Who have implemented something for months was super proud of it. And then in the end, after 3, 4, 5 more weeks, you have to just delete it and drop in with something else. That's happened so often. I think I forgot already how often we have to do this. This fear of like, oh, we need to throw away something. This is so painful. This is actually quite funny because this is actually an economical perspective on like, hey, we have built something, we created value because we invested time and effort and whatsoever. Now we cannot throw it away. Why? We have created it. We don't throw it away. Yeah, right. But sometimes maybe other companies have invested more time, more effort, more money, and bring you an open source solution for, which is better, replacing also your problems. And then this is the actually second part of the quote from ThoughtWorks, which is super funny and interesting because it's like a prediction and look into the glass ball. Because they say at some point in time that if you do not take care and you add tasks and responsibilities and other things to your platform teams, in the end you get nothing else than just yet another shadow DevOps team. And this is something where we really need to take care of. That's why we give a talk today about it, because we need to take care of that this is not like flushed away from too much other things which we maybe should not take care of at all. So if you have a platform engineering team, you should grow one, and grow is the right word because it's not something which you just like can put people in, that's it. Right? You're not going into the forest, dig a very big hole around the tree, take it out, bring it to your garden. No, you need to start with the small things. You need to grow it over time, you give it time, you give water to it, and love and whatsoever, and then maybe it will get what you need and what you have as a platform engineering team. So, short checklist if you want to get started. First one, very important, provide an environment outside of your organizational bullshit. This is a killer for every team itself. Have a clear vision, because otherwise the people do not know in which direction they need to run. They don't need to know the clear path, but it's just relevant to know where I have to go in the end. Give space to grow, for example, budget and time, or to go to KubeCon, and give your project mentality. Give up your project mentality. Platform teams are not there for project; they're there for staying. Thank you.
Thanks so much, Max. Any questions? We are running over time, but let's get one question in.
Thank you. An IT department that I worked in recently was challenged with some of the ways you were kind of justifying the investment, where the IT department is often a cost center. So if you increase revenue, they don't see that benefit. They're still working on a fixed budget.
Yep.
Where do you get the money from to create a platform team in the first place? Where does that money eventually reduce total cost within the IT group?
Mm-hmm. That's exactly where I had this one slide showing you like the 3 numbers and this one like, hey, we do not have downtimes anymore. Right? If you really can enable a team to be faster in the deployment or faster in their daily doing, this is where you save money. It's very hard to track, right? Especially after time. So if you have a team which is running, which is going forward, where everything is happy and fine, you have a problem to justify, like, look, there's still benefits in it. The thing is, if you would cut down the platform, you would see how everything crashes. So this is always a very, very difficult and delicate area where there's help nothing else and go back to Excel and start filling out and like, look, this is how it's get better. And when you're aware of it, you can start tracking this from the early beginning.
All right, and so where do the costs come out, though, right? Because a lot of that description is sort of soft money and not hard money. I can't go say, hey, guess what, there's 10 people I don't need over there anymore because I have this platform team and it's self-service.
Mm-hmm.
Do you ever see it coming back in a way where people can justify that savings back to a very hard-nosed CIO who's looking for those savings in a budget number?
Yeah, again, it is very difficult. So that's why we try to implement from the beginning the approach of like, hey, this is the best practice for reduce also the costs. Whenever something ends up on the platform which we have built, there are reasons, there are tools included from the beginning to reduce the overall costs when you run wherever your cloud environment is running. This helps sometimes because suddenly you can say always like, hey, my platform is never whatever happens is 30% cheaper like when you don't do it. So you try to fill this hole, right? Again, it's always like a big discussion on like how you can really put this up together. And it's from organization to organization very much different. If you have a large organization which have huge processes, a platform team has super hard times because then you have some stuff like, oh, I request a new cloud account. It takes like 5 weeks. Cool. Your process may work, but theoretically process is broken. And then you cannot sell like, hey, with our team, it's way faster, except you found maybe a technical solution to do another way around it. And then you end up in this shadow area where you maybe do not want to get there.
Cool. Thanks. If you have any further questions, please catch Max offline. Let's all move on to the lightning talks. Thanks so much, Max.
Thank you.